Welcome back, guys. This is question 4.1 of chapter 4, which is related to the mathematical expectation. And the statement of our first question is the probability distribution of X, the number of imperfections per 10 meters of a synthetic fabric in continuous rolls of uniform widths, is given in exercise 3.13 on page 92 as the values of X are given and the probability density function of it is also given here. Okay, so that is the density function, or we can also call it the PDF. Okay, so this is the PDF of X. So on the basis of this data, we have to find the average number of imperfections per 10 meters of this fabric. Okay, so we have to solve it, and here we have to find the average number of imperfections, which is basically the mathematical expectation. If you want to find out the expected value of a random variable X, which is also represented as mu, we can always find it out by multiplying the value of a random variable, which is X, with the density function of it. Okay, so this is f of X. And if we have more than one random variable, let us have x1, so we have to multiply it with the fx1, which is the probability density function of x1. Similarly, if we have also x2, so multiply it with fx2, okay, and so on up till and until we have xn, f of xn. Okay, similarly, we can also represent it with what? We can represent it with x subscript I and f x subscript I, where I starts from 1 and ends at n. Okay, so that is the mathematical expectation or the average value. Now here we have the values of X, we have the value of f of X. So what do we have to do here in order to find the expected value of X? Let us multiply the values of X with the corresponding density functions. So here what we will have, let us multiply the 0 with the corresponding value of it, which is 0.41. So 0.41 plus 1 multiplied by 0.37. So 1 multiplied by 0.37 plus 2 multiplied by 0.16, okay, 3 multiplied by 0.05 plus 3 multiplied by 0.05, and here 4 multiplied by 0.01, 4 multiplied by 0.01. Okay, so multiplying them together, what will you get here? It will be 0. Okay, and all other values will become 1 multiplied by 0.37, 0.37 plus 2 multiplied by 0.16, 0.32, 3 multiplied by 0.05, this is 0.15, and plus 0.05, sorry, this is the 0.01, so 0.01 multiplied by 4, so I will have 0.04. Okay, so now adding them all together, what will I get here? The answer of it will be 0.88, and that is the average value which we wanted to find out. Okay, most of the people might have the doubts with respect to the expected value, that how can we find out the expected value like this one, because they have the doubts in their mind that if we have 4 numbers, let us have those numbers as 1, 5, 3 and 2, and if they want to find out their average, what do they have to do? They just add them together, okay, and divide them over the number of items we have. And this is basically the case where all the items are equiprobable, because you can see here that this is the same scenario which we have represented here, because here it can also be represented as 1 over 1 by 4 plus 1 over 4 multiplied by 5 plus 1 over 4 multiplied by 3 plus 1 over 4 multiplied by 2. Okay, so here you can very clearly see that this 1 over 4 is what? that is the probability of each of the item here, because each one of them is equiprobable. So therefore this is 1 by 4. So this 1 by 4, 1 by 4, 1 by 4, 1 by 4, this is what, if you add them together you will get 1. So that is the probability density function, and each number here has been multiplied with the corresponding probability density function. So this formula also holds in our daily life as well, because they are the mathematical expectations are usually called the average of the numbers. Okay, so the same scenario has been used, but here in terms of the probabilities, if you will see them, you will also see the reflection of each method here in each other. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 4.2, and the statement of it is the probability distribution of the discrete random variable x is given as f of x, which is 3 choice x, 1 by 4 raised to the power x, and 3 by 4 raised to power 3 minus x for all the value of x which ranges from 0 to 3. We have to find the mean of x. Okay, so previously we have seen that the mean of any random variable expected value of x is always represented as from I equal to 1 up to n, and the value of the random variable multiplied by with its probability density function here. Okay, so here we can see that the values of I are basically ranges from 1 up to 4, because x1 is 0, x2 is 1, x3 is 2, and x4 is 3. Okay, so the values of x1, x2, x3 and x4 are given, which are here, we can very clearly see, but we don't know the value of f of x. So for x1 equal to 0, let me find the value of f of 0. So putting this value here in this formula, I will have 3 choice 0, okay, 1 by 4 0, because this is x, and 3 by 4 3 minus x. So 3 minus 0 is 3. Okay, so solving it, 3 choice 0 is what, this is 1 multiplied by 1 by 4 raised to power 0 is 1 multiplied by 3 raised to power 3 divided by 4, this will be 27 divided by 64. So ultimately we will get 27 divided by 64. This is for f of 0. Now for x of 2 equal to 1, here the value of x2 is 1. So we will have f of 1 equal to what? This would be 3 choice 1, 1 by 4 raised to power x, which is 1, and 3 by 4 raised to power what? This would be 3 minus x, 3 minus 1, that is 2. Okay, so let me solve it. 3 choice 1 is how much? That is 3 multiplied by 1 by 4 is 1 by 4, and here 339 divided by 16. Okay, so again 27 divided by 64 as well. Okay, similarly x3 equal to 2. Okay, we can see that x3 is equal to 2. Yes, so let me put the value of f of 2 here. So f of 2 would be what? This would be 3 choice 2, which is x. Okay, 1 by 4 raised to power x, so x is now 2. Okay, and 3 by 4 raised to power 3 minus x, so 3 minus 2 is 1 here as well. Okay, so 3 choice 2 is what? This would be 3 factorial divided by 3 minus 2 is 1 factorial, and this is again 3. Okay, 3, so this would be 1 over 16 and multiplied by 3 over what? 3 over 4. Okay, so I will have here 9 over 64. This is for f of 2. Now let me move down somehow to solve it for what? X of 4 equal to 3. This is f of what? This is f of 3, and here we will have the value of x is 3. So now 3 choice 3. Okay, 1 over 4 raised to power 3, because this is x, and also 3 over 4 3 minus 3 is 0. Okay, so 3 choice 3 is how much? This is 1. Okay, 3 factorial divided by 3 minus 3, this is 0 divided by 3 factorial, so I will get 1. So here I will have 1 over what? 1 over 64, and this is 1, so I will get over 1 over 64. Okay, so these are all the values, and we have got different values. Let me plot them here as well. So here we have all the values of what? We have all the values of x and f of x. Okay, so the value of x are 0, 1, 2 and 3. Okay, so here, here and here. Okay, so this 0 is basically what? This is, let me see, that x f of 0 is 27 by 64. Okay, f of 1 is also 27 by 64. Okay, this f of 2, which is calculated, is 9 by 64. Okay, and this f of 3, this is 1 over 64. If you add them together, if you all add them all together, you will see that 27 by 64, 27 by 64, 9 by 64 and 1 by 64, you will get at the end what? 1. So this is what? This is the probability density function. Okay, you can also plot it as a PDF plot. Now, as you have found it out, you can find here the expected value, which is E of x, and for E of x you have to multiply the values which are here with the corresponding values of their probabilities, as we have previously seen. So let me multiply them together, and it would be 0 multiplied by what? 27 by 64 plus 1 multiplied by 27 by 64. Okay, 2 multiplied by 9 by 64. Okay, and 3 multiplied by 1 over 64. Okay, let me add them together. It will be 0 plus 27 by 64. Okay, plus this is 2 multiplied by 9, so 18 over 64, and here it will be 3 over 64. Okay, so adding them together and taking the LCM, let me take the LCM of it, and here I will get the LCM, and it would be 64. So 0 plus 27 plus 3 plus 18. Okay, so it will become 48 by 64, or these two are the multiples of 16, so I will also get 3 over 4. Okay, so the expected value of the random variable which we had here in the form of the formula, we have found out its expected value. Okay, so that's it for today, in which we have found out the mean of a random variable which we were given. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. Let us solve question 4.3 today. So the statement of it is, find the mean of the random variable t representing the total number of 3 coins in exercise 3.25 on page 93. Okay, so previously we have already solved exercise 3.25, so let us move to that page as well. So this was basically question 3.25, and I will put the link to this question in the description box. Similarly, it is also attached as a video card. Okay, so here we have a statement that from a box containing 4 dimes on 2 nickels, 3 coins are selected at random without replacement. Find the probability distribution for the total t of the 3 coins. Okay, so we had solved it, and I told you guys that the probability distribution for this was graphically shown as well, like this one. So similarly, the tabular form of it was also shown here, and it was here. Okay, it was the tabular form From it we can very easily find out the expected value of x, which is e of x. And how can we find it out? By multiplying the value of the random variable with its probability. Okay, each value of the random variable will be multiplied with the corresponding probabilities and then adding them together. Okay, so let me use the same methodology here. So the first one is t equal to 20 and multiplying it with this probability, which is 1 by 5. So 20 multiplied by 1 by 5 plus 25 multiplied by its probability, which is 3 by 5. Okay, and the third one is 30 multiplied by 1 by 5. Okay, so 5 4 20 5 5 25 and 5 6 is here. Okay, so from it we can very easily see that it will be 4 multiplied by 1 and this is 15 and plus 6 multiplied by 1 is 6. So ultimately we will get what? It will be 25. Okay, so the total number here of t, or the expected value of t, which is we can also call t, because here x basically represents t, so that is 25. Okay, so that is the solution of question 4.3, in which we have found out the expected value of the distribution we had previously. So let me put the answer of it in the main question. So in solving it we have found out the answer, and that is basically the expected value of t is 25. Okay, so that is what 25, and the answer of it is here with the units which were given in the question. So that's it for today, and that is related to the mathematical expectations. If you have any question, you can ask in the comment box. See you soon. Hello guys, this is question 4.4 of chapter 4, and the statement of it is: a coin is biased such that a head is 3 times as likely to occur as a tail. Find the expected value of tails when this coin is tossed twice. Okay, so let me first of it write the given data. So in given data we know that the probability of heads is 3 times the probability of tails, so that's why 3 plus 1 would be 4. So therefore the probability of heads is 3 times in 4, while the probability of tails is what? That is 1 times of 1 by 4. Okay, so that is the total probabilities what we have been given here, and here we can very easily see that in adding them together, probability of heads, probability of tails, what would I get? It would be 3 by 4 plus 1 by 4, and here it would be 1, and that is the essence of any probabilistic experiment, that the probability distribution when added together we will get 1 out of it. So what do we have to find out here? We have to find the expected number of tails when this coin is tossed twice. Okay, so the sample space of it, that is also in the given section. So the sample space of it is what? Let me write the sample space of it when the coin is tossed twice. So it can either have heads, okay, or heads tail, okay, or tail heads, okay, or tail tail. So that is what, that is the sample space what we have here. And what do we want to find out? We want to find out the expected number of tails, and in finding the expected number of tails, the formula we have is, if we have the number of tails are represented with t and the random variable representing the number of tails are basically x, so the expected value of x would be what? That would be for x f of x, okay, where this I will be from 1 to any number of items here, and this would be the subscript here. Okay, so that is the formula for the expected value, but we don't know this f of x. Okay, here we want to find out this f of x, and in finding it out here, let me represent the number of tails here with x. So in solving it, that is the solution, and here the probability that we have the number of tails is equal to 0. that is what, let me find out the events where the number of tails is 0, and that is the only event which is here, and the probability of heads we want to find out. Okay, so as the two events here are independent of each other, so therefore it would be the probability of heads multiplied by the probability of heads as well. Let me multiply their probabilities, which are 3 by 4. So 3 by 4 multiplied by 3 by 4, and it would be 9 over 16. Okay, so that is what that is for t equal to 0, or the x equal to 0, which is the number of tails in any event of tossing a coin twice. So here we have, similarly after it, we have to find out the probability that the number of tails is 1. So what are those events? We can see that this is and this one, these are the two events where the number of tails is 1. So therefore we have to find out the probability of heads tail, okay, and tail heads. Okay, we have to find out their probabilities that either this or this event can occur. So we can see that here or is coming in between them, so therefore oring means adding them together. So therefore we will have here heads tail or plus probability of tail heads. Okay, so this is what we have. As again we can see that these are basically the two separate tosses, so the two events are independent of each other, so these events will be, their probabilities will be multiplied with each other. So probability of head multiplied by probability of tails plus the probability of tail multiplied by the probability of heads. Okay, let me put their values, and probability of heads is 3 by 4, probability of tail is 1 by 4, and probability of tail, which is 1 by 4 multiplied by probability of head, which is 3 by 4. Okay, so multiplying them together and adding them together as well, because this is the OR event, because either of these events can occur as I have previously described. So I will get here 6 by 16, which is for probability that tails equal to 1. Okay, so here also the last part is in which we want to find out that the probability that we have got two tails, and that is the only event here in which we have got two tails. So it would be probability of tail. Okay, and as again the two events are independent of each other, so probability of tail multiplied by the probability of tail, multiplying their probabilities, which are 1 by 4 multiplied by 1 by 4, so it would be 1 over 16. Okay, so that is for the tail equal to 2. Now let me put them in tabular form. So in putting them in tabular form, here this is a table which is, let us have this x, the number of tails in two coin tosses, and the distribution of it, let me have here p of x here. Okay, so the values of x can be 0, 1 or 2. Okay, so these are what we had, because previously we have seen that, let me move upward here as well, we have seen that the number of tails in two coin tosses, we can either have the value of it 0 or 1 or 2. Okay, we have also found out their probabilities as well. So for 0 it was 9 by 16, for 1 it was 6 by 16, and for 2 it was 1 by 16. Okay, we can also see it very clearly that when these three will be added together, I will get 1, and that is the prime condition for the probability distribution. Okay, so that is what we had here. Now for finding the expected value of the random variable, which is the number of tails in two coin tosses, we have to use this formula. Okay, in using this formula, let me use the expected value of x, and this would be what, now I have to multiply the value of the random variable with its corresponding probability. So therefore 0 will be multiplied with 9 over 16, okay, and adding them with the other random variable multiplied with the corresponding probability, I will have here 1 over 6 by 16, okay, and after it we have 2, and multiplying it with its corresponding probability, I will have 1 over 16, okay. So after calculating them all and finding them, I will get 8 over 16, which is 1 over 2, okay. So the answer of it is what? That is basically 1 over 2, and that is the solution of our question 4.4. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So in today's video, we will try to solve the relevant questions of chapter 4. So these would be question 4.6, 4.7 and 4.8. Okay, so let us start our video by solving question 4.6. okay, and so the statement of it is, an attendant at a car wash is paid according to the number of cars that pass through. Suppose that the probabilities are 1 by 12, 1 by 12, 1 by 4, 1 by 4, 1 by 6 and 1 by 6 respectively, that the attendant receives $7, $9, $11, 13, 15 and $17 between 4 p.m. and 5 p.m. okay. So the amounts have been written here, and the probabilities of getting this much amount has also been given, okay, respectively. So we have to find the attendant's expected earning for this particular period. So in finding the expected earning, we have a formula, and previously we have seen that this is called the expected value. So expected value of any random variable x can be found out by writing the value of a random variable, multiplying it with the probability it has, okay. So this is what for a single random variable. If we have the multiple random variables, then we have to find out the expected value of it by writing the first random variable, multiplying it with the probability it has, and adding with it the second random variable, multiplying it with its probability, okay, and then x3 px3, okay, until and unless we will reach the last random variable, that would be x of n. Let me write it. Unless and until we will reach x and p x of n, okay. So this is what, this is the expected value of a random variable, okay. So on the basis of this, let me solve question 4.6, okay, and the solution of it is here, okay. It has a solution, and we have different values of the probabilities, which are 1 by 12, okay. So let us find the expected value of a random variable x, and we have probabilities which are 1 by 12 of what? That is of 7, okay, $7. Similarly, 1 by 12 of 9, these are the what? These are basically the, let me write them here, this is 1 by 12 is what? This is the probability, and here x1 is this 7, this is the value of a random variable, okay. So I hope you have understood that why am I writing these values here. So 1 by 12 multiplied with the value it has, that is 9, okay. Also the 1 by 4 multiplied by the value it has, and that is 11, okay, and again 1 by 4 multiplied by the value, that is 13, okay. The next one is 1 by 6, so 1 by 6 with the value it has, and that is 15, and the last one is again 1 by 6 with the value it has, and that is 17, okay. So this is what, this is the formula which we had here, because here this is, this is px1, this is px2, this is px3, px4, px5, px6, while this is x1, x2, x3, x4, x5 and x6, okay. So let me take the LCM of these quantities, and the LCM of it would be 12, okay, and it would be here 12, 1 by 12 multiplied by 12 would be 7 plus 9, okay. here it would be 1 by 4 multiplied by 12 will be 3, 3 multiplied by 11 would be 33, plus 1 by 4 multiplied by 12 is 3 multiplied by 13 would be 39, okay, plus 1 by 6 multiplied by 12 is 2 multiplied by 15 is 30, and the last one is 1 by 6 multiplied by 12 is 2, 2 multiplied by 17 is 34. Okay, so these are the values I have. So now writing them here, I will get 152 divided by 12, and ultimately we will get here 38 divided by 3, which is the answer of question 4.6. okay, and that is the expected value it has. Okay, so this was what? This was question 4.6. okay, now let us proceed to question 4.7. okay, and the solution of it, we are going to write it here, and let us go through its statement. So by investing in a particular stock, a person can make a profit in 1 year $4,000 with probability 0.3, or take a loss of $1,000 with the probability of 0.7. okay, so 1000 loss, a loss of 1000 has a probability of 0.7, and a profit of 4000 has a probability of 0.3. So let me first write this data, and here profit is also written as a positive value because this is always positive, so it is positive, and it has a probability of 0.3. okay, also we have a loss of 1000, and as this is a loss, so I have to write it with the negative value, and it has a probability of 0.7. okay, so this is a given that I have written. What is this person's expected gain? Again, to find the expected gain is basically the expected value. How can we find it out? This would be what? This would be again E of X, and by using the same formula where these are basically the values and these are the probabilities, let me multiply the values with the probabilities, okay, and at the end adding them together. okay, so let me calculate it. So 4000 multiplied by 0.3, it would be $1200. okay, and also this 1000 multiplied by 0.7, and this is as negative, so it would be minus 700. okay, so subtracting 700 from 1200, we will get 500, so it would be 500 USD, and this is a profit of 500 USD, which is the answer of question 4.7. okay, and that is the solution of question 4.7 as well. okay, so you have seen that it is very easy to calculate the probability or expected gain out of any business if you have the probabilities of the profits and loss as well, and this is by using this formula. Next question is also relevant, so let us go through its statement first. So the statement of it is, suppose that an antique jewelry dealer is interested in purchasing a gold necklace for which the probabilities are 0.22, 0.36, 0.28 and 0.14. okay, so let me first write these probabilities. So 0.22, 0.36, okay, 0.28 and 0.14. okay, so these are basically the probabilities given that she will be able to sell it for a profit of $250, sell it for a profit of $150, break even, or sell it for a loss of $150. What is her expected profit? okay, so as their values are also given, let me write this. 0.22 is for $250 profit, so it will be positive. okay, this is 250. This 0.36 is for $150 profit, so it will be 150, positive 150. This 0.28 is for break even, and break even means that he is neither getting a profit nor a loss, so therefore here I have to multiply it with 0. okay, and at the end this is 0.14 for a loss of 150. okay, and in previous question we have seen that for a loss you have to write the negative value with the value of a random variable, so it would be minus 150. okay, and at the end what do I have to do? I have to add these values together for the expected value. Okay, so I have to add them all together, and in adding them all together, what will you get? You will get 88 USD, which is basically the solution of this question which we had here. Okay, so the only part here was basically writing the negative values with the losses, positive values with the profits, and also zero value with the break even values. And this is what this is, again, the expected value of X or expected profit. Okay, so that's it for today, in which we have discussed some relevant questions of chapter 4. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 4.9, and the statement of it is: a private pilot wishes to insure his airplane for $200,000. The insurance company estimates that a total loss will occur with a probability of 0.002, a 50% loss with the probability 0.01, and 25% loss with probability 0.1. Ignoring all other partial losses, what premium should the insurance company charge each year to realize an average profit of $500? Okay, so here some data has been given. Let me first write the given data. Okay, and in given data, let me write the total amount, which is 200,000, and after it we have to see that what amount of loss with the probability it has. Okay, so let me write here the amount. Okay, and let me write here the probability of the amount it has. Okay, so this is basically the loss amount. Okay, let me draw it here, and this is basically the loss amount. So loss amount, initially the insurance company estimate that a total loss will occur. Okay, total loss means all of this amount will be lost, so it will be 200,000. Okay, with the probability of what? 0.002. 0.002 would be the total loss probability. A 50% loss with the probability 0.01. 50% of 200,000 would be 100,000. Okay, so 100,000 with the probability of 0.01. Okay, and the last amount here is the 25% loss with the probability of 0.1. So 25% of 200,000 is 50,000 USD. Okay, so this is what this is, 0.1. Okay, so on the basis of this data, we can very easily calculate the estimated loss. Okay, so the estimated loss here would be estimated loss amount. It can be found out very easily by multiplying each amount with the probability it has. Okay, so all amounts will be multiplied with the probabilities it has and then adding them together. So let me multiply 200,000 with 0.002. Okay, and multiplying it with this one, what will I get? It will become what? It will be 400. Okay, you can multiply it and you can see that it will be 400. Similarly, 100,000 with 0.001, it will be 1,000. Okay, and this last amount would be what? This 50,000 multiplied by 0.1, it will become 5,000. Okay, so you can very easily see that this amount, when multiplied together, it is here. These amounts are here, and these amounts when multiplied together are here. Okay, adding them together, the estimated loss here would be 6,400, and that is the estimated loss. Okay, so that is what we have now. After finding the estimated loss, what we have to do, we have to ignore all other partial losses. What premium should the insurance company charge each year to realize an average profit of $500? Okay, so the average profit per year is always equal to what? That is equal to the premium amount minus estimated loss. Okay, so this is the formula for the average profit. What we have here the amount, and that is what, that is 500 USD, okay, which is given. Premium is not given, we have to find the premium amount here. And estimated loss is basically estimated loss, which is already calculated here, and that is 6400. So let me put it here. Okay, so it will be 6400. Okay, so from this formula we can very easily find that the premium amount here would be what? It would be 6400 plus 500. So ultimately we would get 6900 USD or dollars. Okay, and that is what, that is the solution of the question we were working on. Okay, so the key formula here was this one, and in order to find the average profit, what do you have to do? You have to remember the premium amount, and from it you have to subtract the estimated loss, which we previously found out here as well. Okay, so that is what the solution of 4.9. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 4.10, and its statement is: two tire quality experts examine stacks of tires and assign a quality rating to each tire on a 3-point scale. Let X denote the rating given by expert A and Y denote the rating given by expert B. Okay, the following table gives the joint distribution for X and Y, and on the basis of this distribution, what do we have to find out? We have to find out mu of X and mu of Y, which I forgot to write here. Okay, so this was question 4.10, and on the basis of it we have to find these quantities. Okay, so let me solve it here, and in solving it, what do we have to find out here? In order to find mu of X, I have to write the values of X and multiply it with all the values of g of X. Okay, so let me first write and find the values of g of X. And what are the values of g of X? If for 1 I have to find the value of g of X, it will be all these values added together, and when I will add them, 0.10, 0.05, 0.02, here I will get 0.17. okay, this is for the value of X equal to 1. The value of g of X will be 0.17. so let me write it here. Here it will be for 1 I will have 0.17, and it is added by adding all the values together, for which the value of X is 1. Okay, so you have got my point. After it, I have to find out for the value X equal to 2, and for it we can see that these are all the values here. So 0.10 plus 0.35 plus 0.05, so here it will be 2 multiplied by these values added together, and you will get here 0.5, and here these two must be added together. Okay, similarly plus here, and here I have to see for the value of X equal to 3, and for the value X equal to 3 I have to add all the values of the joint distribution, where the value of X is 3. So 0.03 plus 0.10 plus 0.20, so it would be 3, which is the value of X, multiplied by the value of g of X for X equal to 3, so it would be 0.33. okay, so it would be mu of X. By adding them together, what I will get here, I will get this would be 0.17 plus 1 plus this would be 0.99. okay, so ultimately here I will get 2.16. okay, so that is what, that is for mu of X, and that is the answer for mu of X. Similarly, on the basis of our data, we also have to find mu of Y. okay, and in order to find it out, let me remove it first, and here to find it out, the formula of it would be what? I have to add the values by multiplying the value of Y with the h of y, which is the marginal distribution of y. Okay, so now to find the marginal distribution of y here, let me remove these values here as well, and here I can see very easily that for y equal to 1, these are the values, so therefore I have to add them together. So 0 0.10, 0 0.10, 0 0.03, so it would be what? It would be 0.23. Okay, so let me write it here. Here the value of y is 1, so 1 multiplied by 0.23. Okay, similarly, after add for the value of y equal to 2, I have 0 0.05, 0 0.35 and 0 0.10, so it would be 0 0.5. Okay, so therefore here it would be 0 0.5, or let me first write the value of y, which is 2 multiplied by 0 0.5, and the last one here is these values. This is for y equal to 3, and 0 0.02 plus 0 0.07 plus 0 0.2720, it would be 0 0.27. Okay, so the value of y, which is 3 multiplied by 0 0.27. Okay, so these are basically all the values which we have here. So adding them together, we will get what? It would be mu of y, and adding them together it would be 2.04, and that is what, that is the solution for the value of mu of y. Here you have seen that what are the steps of solving these questions. So first of all, you have to find the marginal distribution for x. Okay, marginal distribution for x, and also the marginal distribution for y. Okay, and then multiplying them with the values of the x and y, and it will give you what? It will give you the average value of any quantity of any variable given in the form of the joint distribution. Okay, so that's it for today. I hope you have understood the concept of these type of questions. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is chapter 4, and today we are going to solve two questions which are closely relevant with each other. So the first question is 4.13, and the statement of it is the density function of the continuous random variable x, the total number of hours in units of 100 hours that a family runs a vacuum cleaner over a period of 1 year, is given in exercise 3.7 on page 92 of the 9th edition of the book, as fx is equal to x for the range of x greater than 0 less than 1, 2 minus x for the range of x which is greater or equal to 1 and less than 2, and 0 elsewhere. Okay, so on the basis of this data, what do we have to find out? We have to find the average number of hours per year that families run their vacuum cleaners. Okay, so again, first of all, we have to find the estimated or expected value, which is basically the average value, and after it we have to multiply it with the units, which is here 100. Okay, so let me first solve it, and in solving it, let me have its solution here. Okay, so the expected value of x here would be what? It will be, okay, this would be the integral of x with the f of x dx. Okay, but here as we have two units, so therefore I have to integrate them separately. Okay, so the first unit here will be the integration from 0 to 1, and it would be the x, and it would be here x as well, which is the value of fx. Okay, so this x is here while the value of fx is here. Okay, and with it I have to integrate it. Okay, similarly with it I have to add the other value, which is again x, the value of x, and with it I have to multiply what? 2 minus x, which is fx for the range of 1 to 2, and then d of x. Okay, so that is what we have. So let me first integrate them, and it would be 0 to 1 x square dx plus 1 to 2. Okay, multiplying this x inside, so I will get 2x minus x square. Okay, and d of x, okay. Or integrating this one, I will get x cube divided by 3, 0 to 1, okay. And integrating them separately because there is a sign of negative here, okay. So therefore I have to integrate them separately, and here integrating it I will get 2 into x square divided by 2, and here it will be from 1 to 2, and also here this would be uh, x cube divided by 3, and it will be from 1 to 2, okay. Let me put these values, and here it will be 1 by 3 plus these two will cancel out, and it will become 2 to 4, 4 minus 1 is 3, okay. And also here it will become what, it will be 1 by 3, and 8 minus 1 is 7, okay. So it would be 1 by 3 plus 3 minus 7 by 3, okay. So let me calculate it, and here it will be, the LCM of it will be 3, and here it will be 1. Similarly plus 9, okay, and here it will be minus 7, okay. So I will get 10 minus 7 is 3, so 3 by 3 is 1, okay. So there is this one, which is the answer. Now in order to find the average number of hours per year that families run their vacuum cleaner, I have to take this value, which is the expected value, and multiply it with the number of units, okay. So the let me start doing it here. So the average number of hours, okay, how can we do it? Multiplying the number of hours in units, okay, so which is 100, and multiplying it with the expected value of ex, which is here 1, okay. So let me put it here as well, and putting it here I will get here 100 as well, okay. And that is what, that is the solution of question 4.13, and 100 hours are the average number of hours that families run their vacuum cleaners, okay. So that is the solution of question 4.13. Let me move to question 4.14. So in question 4.14, we have to find the proportion x of individuals who can be expected to respond to a certain mail order solicitation if x has the density function which is given here, okay. So this proportion of x is basically the expected value, okay. So the same formula has to be employed here. So for this we have to, let me start solving it here, and for it let me write here e of x, okay, and also the x, and the formula for f of x is 2x plus 2 divided by 5, and d of x, and the range of it is from 0 to 1, so therefore I have to write here 0 1, okay. Now simplifying it, moving this 2 by 5 out of it, okay, and here multiplying this x inside of it, what I will get here, it will be 0 to 1, and I will get x square plus 2x, and it will be d of x, okay. Also this 2 by 5 outside, and here 0 to 1 x square dx, and this 2x will become 2 0 to 1 x dx, okay. So now let me solve it again. So it will be 2 by 5, and here it will become x cube divided by 3 from 0 to 1, plus here x square divided by 2, and here multiplying it with this 2 which is here, and it is also from 0 to 1 as well. These two will cancel out, and I will get what, let me move down somehow, okay. So here it will be 2 by 5, so here it will be 1 by 3, okay, and here it will be 1, okay. Also this will be 2 by 5, and here it will be 3, so 4 by 3, okay, because this will be 1 and here it will be 3. So 4 by 3, and multiplying them together we will get 8 by 15, and that is what, that is the solution of question 4.14. okay, so that is what we have, and these are the all of these questions are basically relevant with the mathematical expectation of the continuous random variable or continuous probability density function. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome guys, I hope all of you will be fine. So this is question 4.16, and the statement of it is, suppose that you are inspecting a lot of 1000 light bulbs along which 20 are defective. Okay, so you choose 2 bulbs randomly from the lot without replacement. Let x1 equal to 1 if the first light bulb is defective and 0 otherwise, x2 equal to 1 if the second light bulb is defective and 0 otherwise. Okay, so on the basis of all this data, what do we have to find out? We have to find the probability that at least one light bulb chosen is defective. Okay, so here we are given some data. So on the basis of this data, we can see that we have a lot of 1000. So the given data here is, okay, so the total bulbs are how much? Total number of bulbs are 1000 and 20 are defective. Okay, so the defective bulbs are 20. Now on the basis of this data, if x1 is equal to 1, it means that the first bulb is defective, and if x2 is 1, it means the second bulb is defective, and we have to find the probability that at least one light bulb chosen is defective, which means that if the 2 bulbs are also defective, that is also the required condition here. Okay, so on the basis of it, let me write here the solution. If we have here x1, x2, okay, and we have to see that whether the 2 bulbs are defective or not. So if x1 is 0, x2 is 0, so it means the 2 bulbs are non-defective, and it means the condition is not fulfilled and we don't require it, so therefore it will be not required. Okay, similarly, if we have the 0, this one, what does it mean? It means that the second bulb is defective, so therefore we will require this condition. Similarly, if this is 1, this is 0, this is also the required condition which we need. And also the last one, when 2 bulbs are defective, okay, we can see here that when 2 bulbs are defective, we also need it, because here at least one bulb is written. Okay, so on the basis of this data, what can we find out? If we want out the probability that any of 2 bulbs is defective, we want to find out the probability of it. How can we find it out? We can find it out by 1 minus probability that none is defective. This is the probability rule which we are going to follow here. So on the basis of finding this none is defective, what do we have to see? In order to find the probability of it, let me find here, or let me write here what? Let me write here the total choices, okay, and here the choices of non-defective. Okay, so what are these quantities? So let me write them all. So the total choices here would be what? We have the total number of bulbs 1000, and out of 1000 we have to select 2 bulbs, so these would be the total choices. Okay, what would be the choices of non-defective? What does it mean? That from the 20 defective bulbs you don't have to select any, so it will become 0, and also the remaining 980 which are the non-defective, you have to select 2 out of them. Okay, so these would be what? These would be the choices for the non-defective, and we can see that these are here, and this is the formula which we will be needing here. So this is what, this is the prime formula here, and you have to understand that why did I write it here, and this is because of the written formula which is here written in the plain words. Okay, so let me find it out, and here in order to find out 1 minus 20 0, I will get 1 out of it. Okay, and here this will be 980 factorial, okay, divided by the 2 factorial, and then 990 minus 2, 978 factorial. Okay, whole divided by, sorry, this whole divided by 1000 factorial divided by 2 factorial and multiplied by what? Multiplied by 998 factorial. Okay, so by calculating it, what I will get? I will get 1 minus 0.9604. Okay, and then out of it, what I will get? Let me move down somehow. 1 minus 0.9604, it will be what? 0.040. Okay, and that is what, that is basically the probability that either x1 or x2 is what, these are the defective. Okay, so this plus is for what? This is for or, as we have previously seen, and that is what, that is the solution of the question which we were doing. And from it you can also see that this plus is for what? Here you can also see that this is the table for the OR function. So therefore we had to find out x1 plus x2. Okay, so that is what we have here, and that is the solution of question 4.16. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.17, 18 and 19 of chapter 4, and today we are going to solve questions which are relevant with each other. So in solving question 4.17, let me first solve it and see the statement of it. So let x be a random variable with the following probability distribution, which has been given in the form of this table. So we have to find the mu g of x, where g of x is 2x plus 1. So let us first see that what is this g of x. Okay, so let me solve it first, and in solving it we have to see that what is g of x. So in these type of questions, this is 2x plus 1, which has the domain of capital X, which can be which is basically the random variable, and that random variable is basically small x here. Okay, so in these questions what you have to do, you have to transform this x into another domain, another variable, which is g of x. Okay, which is dependent upon this x. Okay, so similarly here this x has to be transformed into what? This has to be transformed into 2x plus 1 whole square. Okay, so as we will transform this one, so previously we have seen that the expected value of a random variable is basically the weighted sum of what? The weighted sum of the value of the random variable multiplied it with the probability of that variable. Okay, so that is what we have, and we will have to add them together. This is what we had. Now as we will see that this x will be transformed into g of x, so therefore this expected value, or it will become mu g of x. Okay, where this x will be replaced with this g of x, and it will be f of x. Okay, and this will be the weighted sum of this. Okay, so therefore here we have to apply this formula, but before applying this formula we have to use this transformation, that what is basically x and what is the corresponding values of the g of x. So let me first find out all these values for all the values of x, which are -3, -3, 6 and 9. Okay, so here for the value of x equal to -3, we will have g of -3. Okay, and the formula for g of x, we have seen that it was 2x plus 1. So the value of x here will be what? This is -3 plus 1, and whole square. So it will be minus 6 plus 1 is 5, so 5 square is 25. Okay, similarly for the other value of x, which is 6, so x equal to 6 and it will be g of 6. Okay, so putting these values, 2, 6 plus 1 whole square, so it will be 6, 2 multiplied by 6 is 12, 12 plus 1 is what, that is 13, 13 square is 169. Okay, and the last value here is 9, so x equal to 9, and this would be g of 9 equal to what, it will be 2 multiplied by 9 plus 1's whole square, so it would be 9 to 18, 18 plus 1 is 19 and 19 square is 361. Okay, so these are all the values of the g of x which has been obtained from the values of x, which are here, here and here. Okay, so we have obtained another domain here which is the g of x, and let me write these values here. So writing these values here, we will get what? Okay, here we will have this, let me write this with the green color. Here we will have x, here the same f of x, and here g of x. Okay, so the value of x are minus 3, 6, 9. Okay, and the corresponding values of f of x are 1 by 6 as given in the question, 1 by 6, 1 by 2 and 1 by 3. And the values of g of x are, for minus it is 25, for 6 it is 169, and for 9 this is 361. Okay, so these are all the values which we have obtained. Okay, so now in order to find the expected value of g of x, what we have to do, we have to use this formula, and in using this formula we can see that we have to multiply this value with this one, this value here, and this value with this one, and we have to add them together as given here. So let me do it here. So mu g of x will be what? It will be 1 by 6 multiplied by 25. Okay, similarly 1 by 2 multiplied by 169, and 1 by 3 multiplied by 361, and then we have to add them together. Okay, then adding them together, what will we get? We will get the answer equal to 209, and that is what, that is the solution of question 4.17 which we have seen here. Okay, so what is basically the essence of these type of questions? Here we can see that the original values of the random variable has been transformed into another domain or another variable which is basically g of x, and that is the dependent variable of the x. Okay, so that is what we have. Now let us proceed to question 4.18, and here let me remove it first. Welcome back guys, I hope all of you will be fine. So this is question 4.17, 18 and 19 of chapter 4, and today we are going to solve questions which are relevant with each other. So in solving question 4.17, let me first solve it and see the statement of it. So let x be a random variable with the following probability distribution which has been given in the form of this table. So we have to find the mu g of x, where g of x is 2x plus 1. So let us first see that what is this g of x. Okay, so let me solve it first, and in solving it we have to see that what is g of x. So in these type of questions, this is 2x plus 1 which has the domain of capital X, which is basically the random variable, and that random variable is basically small x here. Okay, so in these questions what you have to do, you have to transform this x into another variable which is g of x, okay, which is dependent upon this x. Okay, so similarly here this x has to be transformed into what? This has to be transformed into 2x plus 1 whole square. Okay, so as we will transform this one, so previously we have seen that the expected value of a random variable is basically the weighted sum of what? the weighted sum of the value of the random variable multiplied it with the probability of that variable. Okay, so that is what we have, and we will have to add them together. This is what we had. Now as we will see that this x will be transformed into g of x, so therefore this expected value, or it will become mu g of x, okay, where this x will be replaced with this g of x and it will be f of x, okay, and this will be the weighted sum of this. Okay, so therefore here we have to apply this formula. But before applying this formula, we have to use this transformation, that what is basically x and what is the corresponding values of the g of x. So let me first find out all these values for all the values of x, which are -3, -3, 6 and 9. Okay, so here for the value of x equal to -3, we will have g of -3. Okay, and the formula for g of x, we have seen that it was 2x plus 1. So the value of x here will be what? This is -3 plus 1 and whole square. So it will be -6 plus 1 is 5. So 5 square is 25. Okay, similarly for the other value of x, which is 6, so x equal to 6 and it will be g of 6. Okay, so putting these values, 2, 6 plus 1 whole square, so it will be 6, 2 multiplied by 6 is 12, 12 plus 1 is what? That is 13, 13 square is 169. Okay, and the last value here is 9, so x equal to 9, and this would be g of 9 equal to what? It will be 2 multiplied by 9 plus 1's whole square. So it would be 9 to 18, 18 plus 1 is 19 and 19 square is 361. Okay, so these are all the values of the g of x which has been obtained from the values of x, which are here, here and here. Okay, so we have obtained another domain here, which is the g of x, and let me write these values here. So writing these values here, we will get what? Okay, here we will have this, let me write this with the green color. Here we will have x, here the same f of x, and here g of x. Okay, so the value of x are -3, 6, 9. Okay, and the corresponding values of f of x are 1 by 6 as given in the question, 1 by 6, 1 by 2 and 1 by 3, and the values of g of x are for -3 it is 25, for 6 it is 169, and for 9 this is 361. Okay, so these are all the values which we have obtained. Okay, so now in order to find the expected value of g of x, what we have to do, we have to use this formula, and in using this formula we can see that we have to multiply this value with this one, this value here, and this value with this one, and we have to add them together as given here. So let me do it here. So mu g of x will be what? It will be 1 by 6 multiplied by 25. Okay, similarly 1 by 2 multiplied by 169, and 1 by 3 multiplied by 361, and then we have to add them together. Okay, then adding them together, what will we get? We will get the answer equal to 209, and that is what? That is the solution of question 4.17 which we have seen here. Okay, so what is basically the essence of these type of questions? Here we can see that the original values of the random variable has been transformed into another domain or another variable, which is basically g of x, and that is the dependent of the x. Okay, so that is what we have. Now let us proceed to question 4.18, and here let me remove it first. So the statement of it is, find the expected value of the random variable g of x equal to x square, where x has the probability distribution of exercise 4.2. Okay, so here we have to move to exercise 4.2, and therefore what we will have to see, we have to transform the value of x into x square. So therefore we will have here x will be transformed into x square, because here different values of g of x will be the transformed version of x. Okay, so let us move to question 4.2, which we have previously solved. So this is question 4.2, and I will also put a link of it over here. We can see here that this was basically the probability distribution of the variable with other values, with some values of x which are from 0 to 3, and we have found out the distribution of it here. Let me move. Let us transform this x into x square. Okay, and transforming it will become g of x. Okay, so here let me use this, and let me take g of x here. Okay, so this will be squared, and here the squared value will be 0 as well. Okay, this one will be squared and it will be 1, this 2 will become 4, and this 3 will become 9. So after finding it out, what we will have to do, we have to do the same. We have to multiply it with this one, it with this one, this with this one, and this here, because of the formula here we had. So let us multiply these values. 0 multiplied by 27 by 64. Okay, then 21 multiplied by 27 by 64. Okay, then 4 multiplied by 9 by 64, 4 multiplied by 9 by 64, and 9 multiplied by 1 by 64. Okay, then we have to add them together. Okay, so here we will get 0 plus this will be 27 by 64, 36 by 64, and here it will be 9 by 64. Okay, so solving it, what will we get? Here we will have 72 by 64, which will ultimately give me 9 by 8, and that is what, that is the solution of it, which in which we have found out this value. Okay, which is basically the solution of question 4.18. So the statement of it is, find the expected value of the random variable g of x equal to x square, where x has the probability distribution of exercise 4.2. Okay, so here we have to move to exercise 4.2, and therefore what we will have to see, we have to transform the value of x into x square. So therefore we will have here x will be transformed into x square, because here different values of g of x will be the transformed version of x. Okay, so let us move to question 4.2, which we have previously solved. So this is question 4.2, and I will also put a link of it over here. We can see here that this was basically the probability distribution of the variable with other values, with some values of x which are from 0 to 3, and we have found out the distribution of it here. Let me move. Let us transform this x into x square. Okay, and transforming it will become g of x. Okay, so here let me use this, and let me take g of x here. Okay, so this will be squared, and here the squared value will be 0 as well. Okay, this one will be squared and it will be 1, this 2 will become 4, and this 3 will become 9. So after finding it out, what we will have to do, we have to do the same. We have to multiply it with this one, it with this one, this with this one, and this here, because of the formula here, because here we had. So let us multiply these values. 0 multiplied by 27 by 64.
okay, then 21 multiplied by 27 by 64, okay, then 4 multiplied by 9 by 64, 4 multiplied by 9 by 64, and 9 multiplied by 1 by 64, okay, then we have to add them together, okay. So here we will get 0 plus this will be 27 by 64, 36 by 64, and here it will be 9 by 64, okay. So solving it, what will we get? Here we will have 72 by 64, which will ultimately give me 9 by 8, and that is what, that is the solution of it, which in which we have found out this value, okay, which is basically the solution of question 4.18. So let me move to the main page of it. Welcome back, guys. So this is basically the last question of our series in which we were talking about the similar questions. So this is question 4.19, and the statement of it is: a large industrial firm purchases several new word processors at the end of each year, the exact number depending on the frequency of repairs in the previous year. Suppose that the number of word processors X purchased each year has the following probability distribution, which has been written in the form here, okay. For all the values of X, the f of X has been given. If the cost of the desired model is 1200 per unit, and at the end of the year a refund of 50x square dollars will be issued, how much can this firm expect to spend on new word processors during this year, okay. So again we can see here that this is basically the random variable X, and it has been transformed into the variable after getting the per unit value and a refund amount, okay. So let me solve it here, and in solving it previously we have seen that the expected amount here would be what? Here we have to see the expected amount of g of X, where it will be g of X, f of X, okay, and these has to be added together, okay. But what will be the g of X here? We have to find it out, the value of g of X, what it should be. So we have to deduce it from here, okay. We can see that each of the model here cost $1200 per unit, and also the amount of refund here is 50x square, okay. So this amount $1200 dollar per unit is basically the multiplicative factor. So therefore we will have 1200, and the variable here would be X, okay. Similarly, this 50x square has to be subtracted from the original amount because this is the refund amount, so therefore it will be 50x square, okay. So this is what, this is the value of the g of X which we wanted to find out, okay. So after finding it out, we have to put it here, and then we have to find the e of g of X, okay. But what will be the different values of g of X? It will depend upon the value of X, okay. So x1, x2, x3 and x4, okay. So let me first find out these values. So when X is equal to 0, the value of g of X will be what? It will be putting the value of X equal to 0 here, so it will be 1200, 0 minus 50, 0 square, so here we will get 0 as well, okay. So when X equal to 1, the value of g of 1 will be what? Here I can write 0 as well. G of 1 will be what? It will be 1200 multiplied by 1 minus 50 multiplied by 1 square, okay. This is because of this formula. So what I will get, 1200 minus 50, so it will be 1150, okay. When X is equal to 2 at this value, so it will be g of 2, okay, and it would become 1200 multiplied by 2 minus 50 and 2 square, okay. So it will be 2400 minus 200, so it will be 2200. Okay, so this is for x equal to 2. Let me move to x equal to 3 because this is the last value here. So when x is equal to 3, g of 3 would be equal to what? It will be 1200 multiplied by 3 minus 50 into 3 square. Okay, so it will be 3600, and here it would be 339 and 9 minus 450. So ultimately we will get here 3150. Okay, so these are all the amounts for these values. So let me tabulate it here again, and it will become what? This would be the table here. Okay, and these would be the values of let me write them with this blue color. So it will be x, f of x, and the corresponding g of x. Okay, let me write their values with this color. So it will be 0, 1, 2, 3. It will be 1 by 10, 3 by 10, 2 by 5, and 1 by 5. Okay, and also the values of g of x. For 0 it will be 0. For x equal to 1 it was 1150. For 2 it was 2200, and for 3 it was 3150. Okay, so these are all the values. Now in order to employ the formula which is here, okay, this is the formula which we wanted. Okay, what do we have to do? We have to multiply the values which we have here. So let me move down somehow, and here we can see that we have to multiply this value with this with this. Okay, this one with this one, and this with this one, and we will get the output then. Okay, so we have to find the expected value of g of x, which is basically the expected value of what? 1200 x minus 50x square. Okay, and here we have to employ these values of g of x and f of x. So the value of g of x is 0 multiplied by the value of f of x, which is 1 by 10, plus the value of g of x is 1150 multiplied by 3 by 10. Okay, plus 2200 multiplied by 2 by 5, and the last value is 3150 multiplied by 1 by 5. Okay, so here we have to multiply them and add them together, and ultimately the answer of it will be $1855. Okay, so this is what, this is the solution of our question which we were doing. Okay, so that is basically the answer of question 4.19, and here we have again seen the implication of this formula, that how can we apply this formula for any transformed random variable which has been transformed from x to g of x. Okay, and this is the value of g of x, and ultimately we have also found out the expected value of g of x as well. Okay, so that's it for today. If you have any question, you can ask me in the comment box. So see you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.20 and 4.21 of chapter 4. So let us first talk about question 4.20. Okay, so this is question 4.20, and the statement of it is a continuous random variable x has the density function which is f of x exponential of minus x for x greater than 0 and 0 elsewhere. Okay, so find the expected value of g of x equal to e of 2x by 3. Okay, so now let us first solve it. Okay, and this is 4.20, and here in order to use the formula for finding the expected value, we previously have seen that for a continuous random variable it would be what? Instead of x we have to write here g of x, and we have to multiply it with f of x. Okay, so let me first write the values here. The value of f of x is exponential of minus ex for x greater than 0, and g of x is 2x by 3. Okay, so let me write it here. Okay, so e of x would be f of x is exponential of minus x, and g of x is exponential of 2x by 3. So exponential of 2x by 3, and f of x is exponential of minus x dx. Okay, and also let me put the limit for exponential of minus x, and that is for x is greater than 0, so it would be from 0 to infinity. Okay, let me solve it here again. So it would be what? It would be 2x by 3 minus x dx. Okay, 0 to infinity, and also solving it and then finding it here, I will get 0 to infinity exponential of 3x, 2x minus 3x divided by 3 would be minus x by 3 d of x. Okay, and also integrating it, what I will get here, I will get exponential of minus x by 3 divided by minus 1 by 3 from 0 to infinity. Let me put the values of the limit, and also here I will get minus 3, and here exponential of minus infinity minus exponential of 0. Okay, so ultimately we will get minus 3, here 0 minus 1, so the answer of it will be 3. Okay, so that is what, that is the solution of question 4.20. Okay, so we have solved it by using the formula which is here. Okay, similarly now let me move to question 4.21. Okay, and let me see that what is it asking us. What is the dealer's average profit per automobile if the profit on each automobile is given by gx equal to x square, where x is a random variable having the density function of exercise 4.20 4.12. Okay, so let me move to exercise 4.12 and see that how can we employ this formula there. Instead of x we have to write g of x. So let me move to that exercise. So here we can see that in exercise 4.12, we had the statement that if a dealer's profit in units of $5,000 on a new automobile can be looked upon as a random variable x having the density function, which is given here 2 1 minus x, for the x greater than 0 and less than 1, find the average profit. So here the density function was this one. Okay, we have to use it here as well, but instead of using the conventional function we have to find the expected value of x, uh, for g of x, f of x, okay, and d of x. Okay, so now here, as given in the statement of the question, the value of g of x is what it is here, x square. So let me put these values here, and what I will get, expected value of x would be here, and g of x would be x square, and also the value of f of x is 2 into 1 minus x square d of x. Okay, and also the limits for it are 0 to 1. Okay, let me solve it. So here e of x would be what, from 0 to 1, and multiplying it inside I will get 2x square minus 2x cube. Okay, these two are multiplied together, and then these are multiplied to the 1 minus x square. We, and also here d of x. Okay, now let me integrate them separately. Okay, so integrating them separately, what I will get, 0 to 1 2x square of dx minus 0 to 1 2x cube d of x. Okay, here we will get 2x cube by 3 and 0 to 1, and also 2x4 divided by 4, 0 to 1. Okay, let me put these values here, these limits, and I will get from here 2 by 3, and from here I will get 1 by 2, and ultimately solving it, this will be 6. Okay, and 4 minus 3, so it would be 1 by 6. Okay, so the average value is 1 by 6. Also, let me see that what are the unit values here. So the unit values are 5000. Okay, so what do I have to do? I have to find the expected value here, so therefore I have to multiply the expected value with the unit value, and that is 5000. Okay, so 5000 divided by 6 is how much? Let me calculate it. This would be 833.34. okay, so that is in USD, so it will be the USD, and that is what the answer of question 4.21. okay, so that's it for today, in which we have seen the solution of question 4.20 and 21. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.22, and the statement of question 4.22 is the hospitalization period in days for patients following treatment for a certain type of kidney disorder is a random variable y is equal to x plus 4, where x has the density function given as fx is 32 by x plus 4 whole cube for the value x is greater than 0 and 0 elsewhere. Okay, what do we have to do? We have to find the average number of days that a person is hospitalized following treatment for this disorder. Okay, so in order to find the solution of it, let me find the solution of it, and the solution of it, we have to find the expected number of days that the hospitalized patients find the treatment for this disorder. Okay, so in order to do so, we have to find the expected value, and expected value for this case will be what? This will be e of x for the range of the function of x, which is greater than 0, so it will be from 0 to infinity. And putting the value of x, now x has been transformed from x to x plus 4, so therefore it will be x plus 4, and multiplying it with the f of x, which is the value 32 by x plus 4 whole cube. Okay, so 32 divided by x plus 4 whole cube d of x. Okay, now this will be cancelled out with 1 of it, and it will remain 2. Okay, moving this 32 out of it, 32, and this will be 0 to infinity 1 over x plus 4 square d of x. Okay, or it will be 32 into 0 to infinity x plus 4 minus 2 dx. Now, following the rule for the integration of the powers, what do we have to do? This will be 32 multiplied by x plus 4 minus 2 plus 1. It will be x plus 4 minus 2 plus 1 divided by the minus 2 plus 1, and it will be from 0 to infinity. Okay, let me move down somehow to solve it. Okay, so it will be minus 32, and here it will become 1 over x plus 4. Okay, so this will be 1 over x plus 4, and it will be from 0 to infinity. Now let me calculate it, and in calculating it, what will I get? This will be minus 32, and putting these limits here I will get 1 over infinity minus 1 over 0 plus 4. Okay, so ultimately it will be minus 32 multiplied by minus 1 over 4. Okay, which will be 8 days. Okay, so the answer of this question is what? That is basically the number of days are equal to 8. Okay, so that is what, that is the solution for question 4.22. In our upcoming video, we will talk about the question 4.23. See you soon. Hello guys, so this is question 4.23,
And the statement of it is, suppose that x and y have the following joint probability function, which has been given in the form of this table. Okay, so on the basis of this table, we have to find a, the expected value of g xy square, and in b we have to find the mu of x and mu of y, which are basically the expected values of x and y. Okay, so let us start it from part a. So solving it here, the part a. So now what do we have to do? We have to find the value of gxy xy square. We have to find its expected value. And previously we have seen that the expected value of g of x is what? That is the g of x multiplied by f of x. Okay, and then we have to sum them all together. Okay, here we can see that the g of x is xy square, so therefore writing it here, what I will get here, it will be xy square and multiplying it with the corresponding values of f of x. Okay, so let us see that what are those values. So the first value is 1, and the value of y is 1, the value of x is 2. So what I will get here, I will get 2 into 1 square. Okay, so here 2 and y is 1, so y 1 square, and the value of it, which is 0.10, and that is what? That is f of x. Okay, so I hope you have got it, that from where I have been getting it. So this is the first value. Then for the second one, the value of y is 1 while the value of x is 4. So let me write the value of x, and the value of y is square, and the value of f of x is 0.15. Okay, now let us move to the second row. Here we can see that the value of x is again 2 while the value of y is 3. So it will be 2 while 3 has to be squared because of this formula, and the value of f of x is 0.20. Okay, similarly for it, the value of x is 4 while the value of y is 3. So 4 multiplied by 3 square. Okay, we can see that here, and the value of it is 0.30. Okay, similarly for the last row here, the value of y is now 4 while the value of x is what? The value of x is 2. So 2 multiplied by 5 square and 0.10, and the last value here is 5 4. So x is 4 while this is 5 square and this is 0.15. Okay, at the end what do we have to do? We have to add them all together. Okay, these are what? These has to be added together, and these are the multiplications. Okay, so when we will add them and multiply them together, what will be the answer? The answer of it will be 35.2, and that is what? That is the solution of part A of our question. Okay, similarly, to see the part B of our question, we have to first find mu of x, and mu of x is what? Here we have to multiply the value of x with the corresponding values of the row which are in here, in that row. Okay, so this is, if this is here, so we have to find them all there. So we have to have them all together here. Okay, so the first value of x is 2. Okay, so we have to multiply this 2 with what? With all the values of x which are at 2. Okay, so now we have to do what? Here I have to add 0.10, 0.20 and 0.10, so we will get 0.40. Okay, and then the second value of x is 4. Okay, and then with this 4 I have to multiply the summation of all these values which are for x equal to 2. So what I will get, this will be 0.15 plus 0.30 plus 0.15. So here it will be 0.60. Okay, so here it will be 0.80 plus 2.40. Okay, so I will get 3.2. So answer of it will be 3.20. Okay, that is what? That is the solution of mu of x. Similarly for mu of y, what do we have to do? We have to do the same for all the values of y. So let me first remove them. Okay, and here for the y, these are the values. Okay, we have all these values. So 1 multiplied by 0.10 plus 0.15, so 0.25. Okay, for the second value, which is 3, so 3 multiplied by what? With all these values, which are 0.20, 0.30, so 0.50 plus 5 with all these values, so 5 multiplied by 0.25. Okay, so now adding them all together, this will be 0.250, this will be 1.5, and this will be what? This will be 1.25. We will get here 3, and that is what? That is the solution of mu of y of part B. Okay, so that's it for today, in which we have seen the solution of question 4.23. If you have any question, you can ask me in the comment box. See you soon.
Welcome guys, I hope all of you will be fine. So this is question 4.28, in which we will discuss some important points regarding the plotting of the density function and computation of the expected or mean values. Okay, so let us first go through the statement of this question. So consider the information in exercise 3.28 on page 93. The problems deal with the weight in ounces of the product in a cereal box with f of x equal to 2 by 5 for the range of x, which is given here, and 0 elsewhere. Okay, so this value is constant. You can see that this is 2 by 5 for the range of x greater or equal to 23.75 and less than or equal to 26.25, and 0 elsewhere. Okay, so the first part of it is that we have to plot the density function. Okay, so let me first solve the part A of my question, and in part A of my question I have to plot it, in which on the x-axis we have x, while on the y-axis we have f of x. Okay, so let me plot it here. This is the plot. Okay, this is what? This is x, while here on the y-axis we have the density, which is f of x, while the values ranges from 23.75 to 26.25. so let me have these values from, let me have here 23.75 up to 26.25. okay, and this value is constant, which is 2 by 5. okay, if this is 2 by 5, so the value of it will be constant in between these two ranges. Okay, and it is the value we have here. Okay, so this is what? This is the plot of the density function which we have here. Okay, so this is the density function. Now in part B of this question, we have to compute the expected value or mean weight in ounces. Okay, so which is again the same scenario, in which we have to find the expected value of x, and therefore as this is a continuous function, so therefore I will have to do what? I have to integrate it with x, f of x. Okay, so and also here d of x, and similarly here we have to write the limits, because it limits from 23.75 to 26.25. so we will have 23.75 to 26.25. okay, so what will I get here? Putting the value of f of x, which is 2 by 5, so it will be 2 by 5. Here it will be 23.75, 26.25 x dx. okay, or it will become what? It will be 2 by 5 multiplied by x square by 2, x square by 2, while the ranges of it will be 23.75 and 26.25. These two will cancel out, and also when we will put these values, what will we get? The answer of it will be 25, which is what? Which is the mean value of this function which we have here. Okay, so the mean value basically lies here, which is 25. okay, which is basically at the middle of this
density function. Why in the middle? Because if I subtract this 20 from this 26.25, this 23.75, what will I get? We will get 2.5. okay, so this range or these values are overall 2.5. okay, so therefore if we make it half, what will it be? It will be basically half away from it and half away from it, and this is 1.25 and 1.25, so which means this 25 is basically at the middle of this plot. okay, so therefore in part C it is asking us that, are you surprised at your answer in B? Explain why or why not. We are not surprised because this is a symmetrical function, and in symmetrical function mean basically lies at the middle of it. okay, so that is basically the essence of these type of questions, in which first of all you have to plot the density functions. Here we had the density function in constant value. If you do not have the density function in the constant values, what you will have to do, you have to define the values of x on the x-axis and f of x on the y-axis, and then you will have to plot them. okay, so all those questions will be solved like this one. So if you have any questions regarding the same type of questions, regarding the same type of statements, you can ask me in the comment box. So see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.32, which is again related to the previous questions, but now here we have to plot the table which is for the probability function. okay, so let us go through the statement of it. In exercise 3.13 on page 92, the distribution of the number of imperfections per 10 meters of synthetic fabric is given by this table. okay, so all the values of x and the corresponding probability has been given. So what do we have to do? In part A we have to plot the probability function. In B we have to find the expected number of imperfections or E of x, and in part C we have to find E of x square. okay, so let me start it, and in solving part A of my question, okay, as it is now a table, it is very easy for us to plot it. So now let me plot it here. okay, let me see that how can I plot it here. So let me have here this one. okay, this is x and this is f of x. okay, now the first value here is 0, then 1, 2, 3 and up to 4. okay, so let me use another color. This is blue for the bars. So for 0 we have 0.41, so let me have here 0.41 here. This is 0.41, and let me start it from 0 up to 1. okay, so this is here 0.1, and for 1 we have 0.37, so 0.3 will be somehow here. So let me have here, and it will be from here to here. So this is what 0.37. okay, for 3 we have 0.16, and 0.16 will be somehow here. So 0.16 will be from here to here. This is for this. For 3 we have 0.05, so 0.05 will be somehow here. okay, so let me have it here for 0.05, and for 4 we have what, 0.01. okay, so this is what, this is 0.01, and it will be somehow here, so it will be for this one. okay, so now we have this graph. In order to see it correctly, what do we have to do? I have to point these values here now. okay, so these are all the values which we have to point now. So now we have here, this is 0, this is 1, this is 2, this is 3, this is 4. Now you can see that all these values which are here corresponds with the values which are
now better visible to you. Okay, previous was also good, but in order to see them in a better manner, this is what we have to use in these type of charts. Okay, in many questions and in many places, this 0 is also called 1, this is 2, and so on. That is also correct, but for those we have to do what? We have to rescale them. This should be 1, this is 2, this is 3, this is 4, and then this is 5. Okay, so therefore I am not using that convention, but I have employed this one which I have shown to you guys. Okay, so this is what we have now. To find the expected number of imperfections, what do we have to do? Here we have part B of my question, and to find the value of E of x, what do we have to do? Here we have to multiply each value of x with the f of x. Okay, so let me take these values. So 0 is for x and 0.41 is for f of x. So this will be x1 f of x1 plus x2 f of x2 plus x3 f of x3, and also plus x4 f of x4. Okay, and also this is x5, so we have to have here x5 f of x5. Okay, so let me put these values here. For x1 we have 0, while for f of x1 we have 0.41. For x2 we have 1 multiplied by 0.37. For x3 we have 2 multiplied by f of x of 3. This is what? This is 0.16. Okay, plus x4, which is 3 multiplied by f of x4, which is 0.05, and plus x5, which is 4, and multiplied by f of x5, which is 0.01. Okay, when I will add them together, what will be the answer? The answer of it will be 0.88, and that is what? That is the solution for part B of my question. Okay, so this is what? This is part B of my question. Now in part C we have to find what? We have to find E of x square, and that is very easy. What do we have to do? We have to, instead of using the x, we have to use x square. Okay, and then f of x. Similarly here, what we will have here, as we have seen here, we will have x1 square f of x1 plus x2 square f of x2 plus x3 square plus multiplied by f of x3, and plus x4 square f of x4 plus x5 square f of x5. Okay, why am I using x1 x2 here? You can also use here x0 x1 x2 x3, and that convention will be useful here as well. But as due to the values of the x1, I have been using x1 and x2, but else is up to you, that whatever convention you have to write as a subscript in the values of x, which is feasible to you guys. Okay, so putting these values here we will have 0 square multiplied by 0.41 plus 1 square multiplied by 0.37 plus 2 square multiplied by 0.16 plus 3 square multiplied by 0.05 plus here 4 square multiplied by 0.01. Okay, so that is what we have here. Now finding it out and then adding them together, we will get 1.62, and that is what? That is the solution of part C of my question. Okay, so that's it for today for the question 4.32, in which we have seen that how to find the expected value of the tabular functions, and then how to find the E of x square. This E of x square has other purposes as well, which we will see in our upcoming videos. So thank you so much for you guys, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back guys, I hope all of you will be fine. So this is question 4.33
4.33, which is a separate section, and that section is basically related to the variance of the random variable. Okay, so from today we are going to solve all the questions which are related to the variance and standard deviation. So previously you have seen the mathematical expectation, which was basically mu, and it was basically what if you have a discrete random variable. So mu was basically x into f of x, where x was the random variable or the values of the random variable, while f of x was the probability density of that random variable. Okay, so that is basically mu. Now in order to find the variance of the same random variable, that is basically this one, and this is what this is the, and now here in order to find it out, how can we do it? If we have found out the expected value, so it will be what? It will be x minus mu and multiplied by f of x, while this will be what? This will be squared. Okay, so this is what this one is now called the variance. Okay, while this one is the expected value. Okay, expected value or mean value or average value. Okay, so these are what? These are the values. If you have the I number of x values here, so it will be I, and here all the corresponding values of the probability density function, and similarly here as well it will be what? It will be here and here as well, while mu will remain the same. Okay, this is what we have. Similarly, if you want to find out the standard deviation from the variance, that can be found out very easily by taking the square root of this, and this is what? This one here is called the standard deviation. Okay, so that is the square root of the variance. So that is what? That is the standard deviation. Okay, so now we have all these formulas. By employing these formulas, we will solve all the questions of this section. The first question here is 4.33, and here we have to use definition 4.3 on page 120 to find the variance of random variable x of exercise 4.7 on page 117. Okay, so what is definition 4.3? That is basically this formula. Okay, we have seen that this is the formula, and we have seen that this is the formula of the variance, and also the standard deviation can be found out by using the formula which is mentioned here. So let us move to the question 4.7, that what we did there and how to find the standard deviation. So this is here, this is question 4.7, and the statement of it was, by investing in a particular stock, a person can make a profit in 1 year $4,000 with a probability of 0.3, or take a loss of $1,000 with a probability of 0.7. What is the person's expected gain? Okay, we have found out that its gain was basically $500. Okay, and so now let us find out what? Let us solve it for the variance as well. So let me remove this one here. Okay, we have already known the value of the mu, which is here. This is mu or e of x, and we have seen that the value of the variance can be found out by what? It would be xi minus mu, okay, square into f of xi. Okay, and also we have to add them together, all these values. So now what are x of I here? The first x of I here is 4,000. The second x of I is 1,000. So therefore this is what? This is x1 and this is x2. Okay, so let me open it up. So it will be x1 minus mu square and f of x1 plus x2 minus mu and f of x2. Okay, let me put these values here, and putting these values here, what we will get? X1 is 4,000, so 4,000 minus mu, which is 500. Okay, and the corresponding f of x is 0.3, so let me put it here as well. Okay, also here the value of x2 is what? X2 was the loss, so therefore it was minus 1,000. Okay, similarly mu was again the same, which is 500. So 500, and that is square, also here the square, and the value of f of x2 is what? That is 0.7. So 0.7. okay, now calculating them and then finding out all the values, what we will get here? We will get 5,250. okay, and this one on this is the what? This is in dollar, and that is what? That is the solution of the question which we were seeing. okay, so this is what? This is the utilization of this formula which we have seen in our main page, that how to employ this formula and what are the uses. So this is what? This is the variance which we have seen here. If you want to find out the standard deviation, how to find it out? Just by taking the square root of this value, you will find out what? You will find out the standard deviation which is mentioned here. okay, so that's it for today, in which we have seen the solution of question 4.33. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So today we are going to solve question 4.34 and 4.35, and these questions are again relevant with the questions which we have previously solved, and those are the questions related to variance and standard deviation. okay, so previously I have told you that how to find them out, but now in this question what we are going to use is the theorem 4.2. so what is basically the theorem 4.2? Let me see that theorem 4.2. okay, so let us look at this one. And what is this? This is theorem 4.2. The variance of a random variable x can be found out by this: lambda square is equal to ex square minus mu square. okay, so in these two questions we are going to employ this formula. So let us first go to the question 4.34. so let x be a random variable with the following probability distribution which is given here. All the values of the random variable are given, and the corresponding probability density function is also given. We have to find the standard deviation of x. As we have previously seen, this can also be found out by first finding out the, that is what? That would be this one, and then x minus mu, which is the expected value square, and then f of x. This can also be found out by using this one, and then when you will find out the variance of it, the standard deviation can be very easily found out by this one as well. okay, but it would be very easy and feasible to use this formula as well. But if in question it is not given that which formula to use, you are free to use any one of them. Either you can use this one or this one as well. It is up to you. okay, here you will also find this variance. You will have to find the standard deviation, and this would be what? This would be what you wanted to find out. okay, so here we have this one. So now let me have here this one, and from it, first of all, let me find out the mu. So from this, mu would be what? It would be xi f of xi. okay, so what are the values of x? So this is x1, this is x2, this is x3, this is f of x1, this is f of x2, this is f of x3. so it will be x1 f of x1 plus x2 f of x2 plus x3 f of x3. Let me put their values. So x1 is minus 2 multiplied by what? 0.3. okay, plus x2 is 3, while f of x2 is 0.2. okay, and x of 3 is 5 multiplied by 0.5. okay, so it would be minus 0.6 plus 0.6, and it will be 2.5. so these two will cancel out, and here the value of mu would be what? It would be 2.5. okay, so this is what the expected value is. okay, now in order to find the variance by using this formula, what we have to find out? We have to find out ex square as well, because this one is what? This is e of x. so now we want to find out e of x square as well, and it would be what? It will be xi square and f of xi. okay, let me put these values here as well. so it will be x1 square f of x1 plus x2 square f of x2 plus x3 square f of x3. Okay, now let me put these values. So x1 is -2, so -2 square, f of x1 is 0.3. okay, this is x2 is 3, so 3 square, and here 0.2 multiplied by 0.2, and x3 square, which is 5 square multiplied by 0.5. okay, so calculating it, what we will get here, the answer of it would be 15.5. okay, so this is what 15.5. Now in order to use this formula, this is sigma square, we have to use e of x square, which is here. This is the value of ex square, so 15.5 minus mu square, so mu square here would be here what it would be, mu square would be 2.5 square, so here 2.5 square. okay, so on the basis of it, when we will find it out, the answer of it will be what, it will be 9.25, and that is what, that is the variance of what we wanted to find out. okay, so this is the variance. Now in order to find the standard deviation out of it, what we can use, standard deviation is this, and from it, in order to find it out, we have to take the square root of the variance, and it would be what, by taking the square root of 9.25, it will be what, it will be 3.04, and that is what, that is the standard deviation what we wanted to find out. okay, so that is the standard deviation, or the answer of this is what, this is this, and 3.04. okay, so that is what, that is the solution of question 4.34. Similarly, if you want to find out the variance for the question 4.35, what you can do, first of all, you can employ this formula by for finding out the expected value, and this would be by multiplying these values together. okay, these will be multiplied together and then added, will be added together. You will get what, you will get the expected value. After it, what you will employ here in order to find the expected value of x square, you will square this one and then multiply it with this one, like it will be 2 square multiplied by 0.01, 3 square 0.25, 4 square 0.04, as we have done here. So once you will find all these values, you will have to employ this formula, because in that case as well, you will have the mu and e of x square as well. So you have to practice this question as well by yourself, because these two are very closely relevant with each other. So try it, and if you have any question, you can ask me in the comment box of this question as well. So that's it for today, and I will see you with some more interesting stuff like this one in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.36 to 4.39, and we are going to solve them all together today. So the first question here is the 4.36, and the statement of it is, suppose that the probabilities are 0.4, 0.3, 0.2 and 0.1 respectively, that 0, 1, 2 or 3 power failures will strike a certain subdivision in any given year. okay, so these are the values of a random variable, while these are the probabilities. So let me first write them. So this is the solution, and in solution of it, let me first write the values, and the values it has are 0, 1, 2, 3. So 0, 1, 2, 3, and their corresponding probabilities are 0.4, 0.3, 0.2 and 0.1. okay, these are the probabilities of them. okay, or we can also call it x, and this is what, this is f of x. okay, these are all the values of the f of x. So now it is clear. So what do we have to find out? We have to find the mean and variance of the random variable x, representing the number of power failures striking this subdivision. okay, so now the first thing here is to find the mean, which is the expected value of x, or mu, and we can see that it is very easy to find it out if we have the values of x are xi. So these has to be multiplied with f of xi. So now here taking this is x1, x2, x3, x4, while this is fx1, fx2, fx3 and fx4. Let me write these values. So 0 multiplied by 0.4 plus 1 multiplied by 0.3 plus 2 multiplied by 0.2 and plus 3 multiplied by 0. What? 0.1. This is 0.1. Okay. So what did we do? We have multiplied each term here and then added them together, because this is the formula for the expected value. Okay. So this is the solution of the question. Now let me find it out. It would be 0 plus it would be 0.3 plus it would be 0.4 plus and it would be 0.3. So adding them together, what will we get? We will get 1, which is the answer for the expected value or average value. Okay, so this is what we had found out. Now in order to find the variance of it, what do we have to do? We have to employ the formula which we have previously seen. That what was that? And it was the sigma square is equal to expected value of x square minus mu square. Okay, we have to employ this formula. Okay, this mu or e of x has been found out, and this is where it is already here. This is mu. Okay, similarly the value of mu square will also be 1, because this will be the square of 1. So square of 1 is also 1. Now what do we have to find out? We have to find e of x square. So in order to find the value of e of x square, it will be what? It will be the here I and x of I square multiplying it with f of xi. Okay, so what do we have to do? We have to multiply the square of each term with the corresponding probabilities. So let me do it. It will be 0 square multiplied by 0.4, okay, plus 1 square multiplied by 0.3, which is the probability it has, plus 2 square multiplied by 0.2, okay, and also now 3 square multiplied by 0.1. So it will be what? It will be 0, it will be 0.3, okay, it will be 2 to 4, 4 multiplied by 0.2 is what? It is 0.8, and it would be 339, so it would be 0.9. So what will we get here from it? This is 2. Okay, so the value of it is 2. Now in order to find the value here, in order to find the value of the standard deviation, let me put the value of ex square, and that is what? This is 2. Okay, the value of it is 2, which is already found out, minus the value of mu square, which is already known, and that is 1. So I have put it here. So 2 minus 1 is 1, and this is what? This is the value for the standard deviation, which is represented by this sigma square. Okay, so these are the two values which we have found out. This is mu and this is sigma square, and this is for the mean and this is for the variance. Sorry, this is for variance, not standard deviation. If you want to find out the standard deviation out of it, you have to take the square root of it. So this is variance and this is mean of it. So this is the solution of question 4.36. Now let us proceed to question 4.37, and it is asking us to find the variance of x, and what is x? A dealer's profit in unit of $5,000 on a new automobile is a random variable x having the density function given in exercise 4.12 on page 117. Find the variance of x. Okay, similarly for question 4.38, 4.39, we have all the density functions in the continuous random variable form. So we will follow the same procedure what we will do for question 4.37, and it will also be a hint for the question 4.38 and 4.39 as well. So let us move to question 4.12, and let me see that what did we do there. So this was question 4.12, in which if a dealer's profit in units of 5,000 on a new automobile can be looked upon as a random variable x having the density function which is given here as f of x is 2 1 minus x for the range of x is greater than 0 and less than 1 and 0 elsewhere. So on the basis of it we have found out the expected value of it. Now what do we have to do? We have to find the variance for it, and in order to find the variance for it we know the formula, and that is sigma square is equal to ex square minus mu square. So what do we have to do here? Again, by using the same formulation in which we have the integration, and I have to use here the x square f of x and d of x for the range of f of x which is from 0 to 1, which we can see here as well. Okay, so this is due to the fact that we have this is from 0 to 1 and the value of f of x is 2 1 minus x. So let me put this value here. This is 2 1 minus x. Okay, so it will be 0 to 1, and here it would be x square multiplied by 2 1 minus x d of x. Okay, so let me solve it, and in solving it it will be 0 to 1 and 2x square dx. Okay, and minus 0 to 1, because I have been taking all these steps directly, because you know the basic rules for the integration that it is a linear process, so therefore I have been taking them separately. And also here we will get 2x cube dx. Okay, so now taking them and integrating them we will get x cube divided by 3 multiplied by 2, and it will be from 0 to 1 minus it will be what 2 multiplied by x 4 divided by 4 0 to 1. Okay, or it will be what here it will become 1 and 1, so 2 by 3 minus it will be what it will be 2 to 4, so it will be 1 by 2. Putting these ranges here will give me 1. Okay, so 1 minus 0 would be 1, and also here what will we get here? It will be 6. Okay, the LCM of it is 6, so 3 2 is how much? So 6 multiplied by 2 by 3 3 to 6 2 to 4 minus 1, and also here this is 1 by 2, so 1 by 2 multiplied by 6, this 1 by 2 multiplied by 6 is what? This is now 3, so what will I get here? Again it will be 1 by 6, so the value of ex square is also 1 by 6, while the value of mu here was 1 by 3. Okay, it was here, this was mu for this question. So now let me put these values here. For e of x square is 1 by 6. Okay, this is what this is e of x square, and also this was 1 by 6, so it was 1 by 6, while the value of mu was 1 by 3, so it will be 1 by 3 square. Okay, so it would be 1 by 6 minus 1 by 9, and ultimately we will get what? The answer of it will be 1 by 18. So that is what? That is the solution for the variance of what we wanted to find out. Okay, so this is 1 by 18, but here we have another point, and that is this scaling point. Okay, we had this unit, so therefore what do we have to do? As we had found out the variance, so the variance here would be 5,000 square, and with it I have to multiply the scaled variance, and that is 1 by 18. Okay, so now let me calculate it, and the actual variance in this units 5,000 units would be what? This would be the answer what we wanted to find out, and it will be the actual solution what we have. Okay, and that is what? That is the solution for the question which we have. So we have found out the solution for question 4.37 as well. Now for the question 4.38 and 4.39, what do we have to do? We have to follow the same procedure what we have done for question 4.37, and here we had to employ the same formula, and this is here sigma square is equal to Ex square minus mu square, because all the values of for mu and mu has already been calculated. What do we have to do? We will have to find the value for Ex square, and then finding it out we have to subtract mu square from it. Okay, and that would be the solution for the same question. What is the difference here? The difference between 4.36 and these three questions is that for question 4.36 we have the discrete random variable, while for these three we have a continuous random variable, which we have seen for the question 4.37. okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys, and today we are going to solve three questions which are related to the variance of a random variable. Okay, so we are going to solve question 4.40, 41 and 42. So let me solve first question 4.40. okay, so in this question, referring to exercise 4.14 on page 117, find sigma square g of x for the function g of x 3x square plus 4. okay, so in solving it, so solution of it, let me use the black color. In solving it, we have from exercise 4.14, you can see that it is what? It is 2 by 5 x plus 2. okay, and this is for x greater or equal to 0 and less than equal to 1, and it is also 0 elsewhere. okay, so we can see that this is what these are basically the values we have to use here. okay, so now g of x will be what? G of x is 3x square plus 4. okay, so let me move down somehow, and here first of all we have to find what? We have to find the expected value, and here expected value would be e of g of x, which I have portrayed here as well. okay, so it would be what? It would be from 0 to 1 and g of x f of x dx. okay, let me put these values. So it would be 0 to 1, g of x is 3x square plus 4, and f of x is 2 multiplying it inside, so I will get 2x plus 4 divided by 5, and here d of x. okay, so let me solve them just by multiplying them and taking it outside of it. What I will get, it would be 1 by 5. okay, and here these would be 0 to 1, 6x cube plus 12x square plus 8x plus 16. okay, and it would be what? It will be d of x. okay, finding them all and then integrating them, because addition is basically the linear process and also integration is also linear. So therefore taking the integral of all of them, so what will we get? We will get here 6 into x of 4 divided by 4, 0 to 1, plus 12 multiplied by x cube divided by 3, 0 to 1, plus 8 into x square divided by 2, 0 to 1, plus here it would be 16 into x 0 to 1. okay, so finding them all and then ultimately calculating it, what I will get here, the answer of it would be 5.1, and it is what? It is mu of g of x. okay, so this is what? This is the mu of g of x. Now in order to find the value of the variance, what do we have to do? Let me move down somehow. Now employing and finding g of x square, what it would be, as I previously told you, that it would be g of x minus mu g of x whole square. okay, and also here it would be from 0 to 1 and g of x minus mu g of x square f of x d of x. Now let me write their values. So the value of g of x is 0 to 1. That is what? That is 3x square plus 4. 3x square plus 4, and this is what? This is 5.1. So minus 5.1 whole square. Okay, and this f of x, this is how much? This is, we have previously seen that this is 2x plus 4 divided by 5, and this is d of x. Okay, now then calculating it and then finding it out, we will get 0 to 1, 3x square minus 5.1 to this would be 1.1 square. Okay, and 2x plus 4 divided by 5 d of x. Okay, then opening up this, just like a plus b whole square is equal to a square plus 2ab plus b square, and then multiplying them out, and then ultimately we have to apply this integration. What would we get? Ultimately the answer of it would be 0.83. Okay, and that is what? That is the solution of the question we have followed. Okay, so the underlying processes and strategies, whatever we have followed, will remain the same for question 4.41 and 4.42 as well. Here we can see that g of x is given, here g of x is given. We will have some density function, and applying the same formulation which we have done here as given in this formula, we can find the solution of them very easily. Still, if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.40, and today we are going to solve 3 questions which are related to the variance of a random variable. Okay, so we are going to solve question 4.40, 41 and 42, and the underlying concepts in all of these is that here we have to find variance. Similarly here also we have to find the standard deviation, which is the square root of the variance, and similarly using the results of exercise 4.21 here as well, we have to find the variance as well. Okay, so in all of these questions we have to find the variance, and the strategy in all of them will be the same. Here we have to find what? In order to find the variance of any random variable, okay, we have to do what? We have to find the expected value of it, which is what? In continuous random variables, these are x, f of x, d of x. Okay, and let me call it mu. Okay, after finding out the mu, we find the expected value of x minus mu square. Okay, and this is what? This would be x minus mu square as well, because here we can see that we have replaced this x with this x minus mu, while others will remain the same, and here it would be f of x, d of x as well, and so it would be what? It would be the sigma square of x, and this is what? This is the variance. And in order to find the standard deviation or sigma, we have to do what? We have to take the square root of this sigma. Okay, so this is for the conventional random variables. Now if we have some other random variable, just like here g of x, how can we find out the mean and variance for all of them as well? We can find out the expected value of any other value here as well. So this would be what? Here we have to do what? Just instead of x, we have to write here the g of x. Okay, so just like here, if you want to find out the expected value of g of x, how would it be? It would be g of x, while the original density function will remain the same, and here it would be d of x, and let me call it mu g of x. Okay, similarly now if I want to find the variance of it, it would be what? It would be g of x minus mu g of x square. Okay, and now replacing this g of x with the new value, which is g of x minus mu whole square. Let me make it more clear. So it would be expected value of the g of x minus mu of g of x, okay, and also the square of it, okay. So how it would be, replacing this one with the new value, which is g of x minus mu g of x, okay, and square of it, and with it f of x, okay, and d of x, okay. So this would be what? This would be the sigma square g of x, which is what? Which is the variance of the g of x, okay. And in order to find the standard deviation of it, we can use the square root, which would be g of x whole square. So from it we will get sigma g of x, okay. So this is what, this is the strategy we are going to follow here, and in all of these questions we will follow this strategy, okay. This is for the conventional random variables, while once we will transform any specific random variables to any other value, just like g of x, and here what has happened, we have transformed x into g of x, and these are all the values given here, okay. We can see that these are all the values, okay. So in all of them the strategy will remain the same, which is now here.
Welcome back, guys. This is question 4.43 of chapter 4, and the statement of this question is the length of time in minutes for an airplane to obtain clearance for takeoff at a certain airport is a random variable y equal to 3x minus 2, where x has the density function, which is here, okay. That is f of x equal to 1 by 4 exponential of minus x by 4 for x greater than 0 and 0 elsewhere. For this random variable y, we have to find mean and variance, okay, of the random variable y, which is given here, okay. So let me proceed with it, and let me choose this black color for it. So this is the solution. So in solving it, first of all we have to find the mean of y. So expected value of y would be what? Expected value of y would be the expected value of 3x minus 2, okay. Or using the previously used formula, what we would get, we would get 3 multiplied by the expected value of x minus 2, and this is why, because we have seen that the expected value of ax plus minus b, this is what? This is the a multiplied by the expected value of x and plus or minus expected value of b, which is basically b here, okay. So this is what we have to find out, and let me call it equation a, okay. Also to find out the variance of y, this would be what? This would be the variance of 3x minus 2, okay. In finding out the variance, we have seen that only the multiplicative term will have the effect over here. So it would be the 3 square variance of x, okay. So this is what we have, and let me call it equation b, because this additive or subtractive term will be neglected here. So first of all, in all of these equations, we can see that here we have to find the e of x, and here we have to find the sigma square of x. So first of all, we have to treat this x and have to find the mean and variance of it as well. So let me first find them out, okay. So let me use this blue color for them, okay. For this blue color, for this blue color. So the expected value of x here would be what? It would be here, let me transform it into the integral here, because we have to find out the expected value of x. So it would be the integral from 0 to infinity, because this is x greater than 0 and 0 elsewhere. So it would be x multiplied by the f of x dx let me put the values here. So it would be the from 0 to infinity x multiplied by 1 by 4 expected value of minus x by 4 d of x. Okay, this 1 by 4 is a constant, so this will be the outside, and here we would get the 0 to infinity x multiplied by minus x by 4 and d of x. Okay, so this formula is what? This is basically the integration by parts. Okay, integration by parts. Okay, so in integration by parts, if we have, let me use this color for it, if we have some variables u and v and we have to integrate them with respect to x, so let me integrate them. So what would we do here? We would do u integral of v dx minus the integral of derivative of u multiplying it with the integral of v dx and dx. Okay, so let me use the same formulation here where u is x. So let me put here u is x and v is exponential of minus x by 4. So how would we proceed here? So let me proceed here as well. So it would become the integral of x of multiplied by minus x by 4 d of x, putting it here in the form of definite integral because these has the limits. So this would be from 0 to infinity. It would become x 0 to infinity exponential of minus x by 4 d of x, and also minus 0 to infinity, and here it would become what? Dx by dx, multiplying it with the integral of v, while this one would not be the definite integral, so therefore it would be the exponential of minus x by 4 dx and the overall dx. Okay, so I hope you have got it. So let me move down somehow to solve it. So solving it, we would get here x multiplied by exponential of minus x by 4 divided by minus 1 by 4 from 0 to infinity minus 0 to infinity. Okay, so it would become 1, and inside of it we would get what? It would become minus 4, okay, multiplied by exponential of minus x by 4, because this integral is basically here, and it would become, this would become 1, and this is what? This is here, these two terms. Okay, so here we would get d of x. Okay, putting limits here, we would get that from here we would get 0, while here it would become plus 4, and integral from 0 to infinity exponential of minus x by 4 d of x. Okay, so finding it out and then solving it, what would we get? The answer of it would be 16, and you can try it yourself as well. Okay, so it would be 16. Let me take it and put this value here. So putting it here, we would get the expected value of x is 1 by 4 multiplied by, this value is known and this is 16, so it would be the 4 here. Okay, so expected value of x is 4. Let me move upside and see that how to find out the expected value of y from it. So here the expected value of y can be found out from the formula A. So let me use it. So the expected value of y from here would be what? It would be the 3 multiplied by the expected value of x, which is known, which is 4. 4 minus 2. So it would be what? It would be 10, and that is what? That is the solution of our question here. Okay, so this is what? This is the mean of the question 4.43. Now in order to find the variance of it, we have to use the formula B, and for it we have to find out the variance sigma square of x. So let me move down somehow again. So for it, let me use this brown color. So to find out the sigma square of x, we have the formula, and that is the expected value of x square minus expected value of x whole square. Okay, so this value is already known. This is known, and we have found it out from it. Okay, this is known, we can find the square of it. While to find out the expected value of x square, let me use another formulation, and for it let me use this blue color as well, and let me call it equation C. Okay, so to find out the expected value of x square, what we would do, we would do the overall formulation just like here, f of x, okay, d of x. Okay, the same formulation which we have done here, but here we have x square. So putting the values here, we would get here 1 by 4 integral from 0 to infinity x square exponential of minus x by 4 d of x. Okay, so that's what we have to find out. So again, finding all the values from it and then putting those values in C, the value of sigma square of x would be what? It would be 16 as well, and that is what we have. Okay, so from it, let me find out the value of the sigma square of y, and as we have seen in equation B, let me move to equation B here. Okay, we can see that this is 3 square sigma square of x, which is here. Okay, this is here. So let me multiply with it 3 square, which is 9. So it would be 9 multiplied by the sigma square of x, which is 16. So ultimately the answer of it would be 144, and that is what? That is the variance of the question 4.43. The only tricky part here is finding this integral. Okay, but I have told you that how to find it out. We have to use this formulation, and it would be very easy for you to find out this integral. If you have any question regarding this integral by parts equation, you can ask me in the comment box. Okay, so that's it for today, in which we have seen the solution of question 4.43. Many of the students asked me to solve it for their exams. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.44, and the statement of this question is find the covariance of the random variable x and y of exercise 3.39 on page 105. Okay, so the solution of that question has been placed to it. Okay, so the link of it is also available in the description as well. So the statement of that question was from a sack of fruit containing 3 oranges, 2 apples and 3 bananas, and random sample of 4 pieces of fruit is selected. If x is the number of oranges and y is the number of apples in the sample, find a the joint probability distribution of x and y, which is what we need. Okay, so from that question we found that the joint probability function of it was f x y, this was equal to 3 choose x, 2 choose y, and also 3 4 minus x plus y, okay, whole divided by 70, and this is for x 0 1 2 3, okay, and y equal to 0 1 and 2. Okay, so this is what, this is the formula which we are going to use in our question for the joint probability distribution. Okay, so this is the formula. Now what do we want to do? We want to find out what, here we want to find out the covariance, which is xy equal to what, the expected value of xy minus mean of x and mean of y. Okay, so this is the formula A, and in which we have to find these values. First of all, let us find out E xy. Okay, so this E of xy is equal to what? This is for all x values, this is for all y values, all the values of xy, and multiply them with this f of xy. Okay, so all of these values would be what? We have all these values, leaving these zeros apart, because 0 multiplied by anything would be 0. Okay, so therefore now what do we have to do here? The value for the first x would be 1 multiplied by 1, x is 1, y is 1, multiplied by f of 1 1. Okay, similarly plus x is 1, y is 2, so 1 2 multiplied by, sorry, this is multiplication, 1 multiplied by 2 multiplied by f1 2. Okay, similarly after it we have to take this 2, so 2 multiplied by 1 multiplied by f of 2 1. Okay, adding it with 2 multiplied by 2, 2 multiplied by 2 multiplied by f of 2 2. Okay, and the last one here is now 3 multiplied by 1 multiplied by f of 3 1 plus 3 2. Okay, so 3 multiplied by 2 multiplied by f of 3 2. Okay, so these are all the values which we have found out, and in our previous question, which was question 3.39, I have told you that how to find out different values here. Finding all these values and putting those here, what would we get? The answer of it would be 9 by 7. Okay, so the value of E of x y is 9 by 7. So this is the value of the expected value. Okay, so now which value is left? These two values are left. So to find them out, let me move down somehow. Okay, so here let me first find out mu of x. So mu of x is what? This is again the mean value, and in order to find it out, taking all the values of x and multiply them with fxy. Okay, multiplying all values which are starting from 0, so 0 multiplied by f of 0 0 plus 1 multiplied by f of 1 0. Okay, plus 2 multiplying it with f of 2 0. Okay, and taking all these values until and unless we get all these two values. So here taking it where the value of it is 3 and it would be 3 2, what would we get? Calculating it and then adding these values, the answer of it would be what? 3 by 2. Okay, so the value of mu of x is 3 by 2. Similarly, finding the value of mu of y, it would be taking all the values of y, multiplying them fx of y, okay, doing the same procedure what we have done here, but all the values of y will be included here because here all the values of y are here, okay, these are the values. So finding them out, we will get that it is 1, okay. So now we have got this value, now using formula A and putting all these values. So it would be sigma xy would be equal to what? It would be 9 by 7 because e of xy is 9 by 7 minus mu of x multiplied by mu of y. So it would be 3 by 2 multiplied by 1. Okay. So calculating it, what would I get? The answer of it would be minus 3 over 14, and that is what? That is the solution of question 4.44. Okay, so that's it for today, in which we have found the solution for question 4.44, which is related to the covariance of a matrix. So there is a difference between a variance and a covariance. Variance is a mode of a single random variable, while in covariance we have to find the variance of a single random variable with respect to the other random variable. Okay, so that's it for today, in which we have discussed the essence of the covariance and how to find it out, and the formula for it is given here, which we will use in our upcoming videos as well. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.45 of chapter 4, and the statement of it is find the covariance of the random variables x and y of exercise 3.49 on page 106. Okay, and this question 3.49 has also been pasted here, and the statement of that question was basically let x denote the number of times a certain numerical control machine will malfunction 1, 2 or 3 times on any given day. Let y denote the number of times a technician is called on an emergency call. Their joint probability distribution is given as this table. Okay, this is the table, and I will also put a link of this question in the description box, and the video card will also be pasted here as well. Okay, so this is what we have. In order to find the covariance matrix of it, what do we have to do? This is the solution, and the covariance of it is what? That is sigma xy, and it is expected value of xy minus mu of x and mu of y. Okay, so this is the formula which we have to apply here. Okay, while finding this mu x mu y, we must have the marginal distribution of x and y as well, which we have already found out. Okay, which was basically the solution of question 3.49. So let us move to that question and see that how can we find out mu x and mu y. So let us go to that question. So this was basically question 3.49, and here we have already found out the marginal distribution for x and for y as well. Okay, and here in order to find the value of mu of x, what do we have to do? Let us choose this color. So mu of x here would be what? We have to multiply these values, okay, and then add them together. Okay, so multiplying this 1 with 0.10, we will get 0.10. Okay, 2 multiplied by 0.35, this would be 0.70. okay, this is here. Okay, and also 3 multiplied by 0.55, so this would be what? 1.65. Okay, so the answer of it would be 2.45. okay, so this is for mu of x. Also finding the value for mu of y, here it would be what? Multiplying it, then this, then this. Okay, so 1 multiplied by 0.20. okay, so it is here. Also 3 multiplied by 0.5 is 1.5, this is here, and the last one is 5 multiplied by 0.3, so it is also 1.5. okay,
this is here as well. So finding it out, what would we get here? It would be 3.20. Okay, so mu of x, let me write them here. Mu of x is what? This is 2.45 and mu of y is 3.20. So these two quantities have been found out. So let us move to our question. Okay, so the values of mu of x and mu of y has been known. So the mu of x is 2.45, mu of y is 3.20. Okay, so these are known, but we don't know the value of e of xy. So let me find it out. So e of xy would be what? It would be x, y, okay, xy and f of xy. Okay, so let me write all these values for xy and f of xy. So for 1 when x is 1, y is 1, what it would be? So it would be 1 multiplied by 1 and it would be f11. So f11 is 0.05. Okay, so let me write it directly here. So it would be 0.05. Okay, with it I have to multiply and add this value. So it would be 2 multiplied by 1 multiplied by 0.05. Okay, now this value, so it would be 3 multiplied by 1, which is the value of y here, and with it this is 0.10. Okay, also now this value, so here x is 1, y is 3, and with that 0.05, which is the value here, which is fx of y. Similarly, with the other one, I will have 2 multiplied by 3. 2 multiplied by 3, with it I have to multiply 0.10. Okay, and this one is now here, which is 0.35, so it is 3 multiplied by 3 multiplied by 0.35. Okay, then now this one, so 1 multiplied by 5 and multiplied by 0, 1 multiplied by 5 multiplied by 0 plus 2 multiplied by 5 multiplied by 0.2. Okay, and the last one is 3 multiplied by 5 multiplied by 0.10. Okay, so at the end, adding them all together, what will be the answer? The answer of it is 7.85. Okay, so now taking these values and putting them in formula A, so it would be sigma xy, so it would be the 7.85 minus mu x, which is 2.45 multiplied by 3.20. Okay, so it would be 7.85 minus 7.84. So the answer of it would be 0.01, and that is what, that is basically the solution of question 4.45, in which you have seen that how to find out the values of the covariance. Okay, so that's it for today, in which we have seen the solution of question 4.45. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.49, and the statement of this question is: consider the situation in exercise 4.32 on page 119. The distribution of the number of imperfections per 10 meters of synthetic failure is given by this table. Okay, we have to find the variance and standard deviation of the number of imperfections. So now, in order to solve this question, we know that the formula for the variance is, if you want to find out the variance of x, the formula of it would be e of x square minus e of x whole square. Okay, so this is the formula which we are going to use in today's question. Okay, so first of all, in order to find it out, what do we have to do? We have to find out e of x. So in order to find the value of e of x, what do we have to do? We have to multiply these pairs. Okay,
and then add them together. So here, in order to multiply them, the first pair here would be 0 multiplied by 0.41. So 0 multiplied by 0.41, then 1 multiplied by 0.37, 0.37, 2 multiplied by 0.16, 3 multiplied by 0.05, and the last one is 4 multiplied by 0.01. Let me write it here, 4 multiplied by 0.01. Okay, and then add them together. Okay. Why is it? Because we know that the formula for E of x is x of I multiply it with probability of x of I and then adding them all together. Okay, so adding them all together, what will we get? The answer of it would be 0.88. Okay, so this is for what? This is for E of x. Now in order to find the value of E of x square, okay, it would be what? It would be the multiplication of x square with its probabilities, okay, and adding them all together. So here, getting the values of x, which is here 0, 1, 2, 3, 4, squaring them and then multiplying with the probabilities which are here. So let me use them. It would be x square equal to 0 square multiplied by 0.41, which is here, okay, plus 1 multiplied by 0.37. Okay, so 1, why? Because this is 1 square, 0.37 plus 2 square multiplied by 0.16, 2 square multiplied by 0.16, okay, 3 multiplied by 0.05, so 3 square multiplied by 0.05 and plus 4 square multiplied by 0.01, 4 square multiplied by 0.01. Okay, so now calculating them and then adding them all together, the answer of it would be 1.62, and that is what? That is for E of x square. Now taking these values and putting them here in this equation, what would I get? The variance of it would be E of x square. This is given and this is 1.62 minus E of x, which is 0.88, so 0.88 whole square. Okay, so calculating it and then finding the answer of it, it would be 0.84. Okay, so the answer of it is 0.84, which is what? Which is the variance of the provided table. Now in order to find the standard deviation of it, let me represent it with S of D. This can be found out by variance of x square root. Let me put this value here, so it would be 0.84 and square root of it would be what? The square root of it would be 0.92, and that is what? That is for the standard deviation. So we have found out the variance and standard deviation by using the formula which is given here. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.50 of chapter 4, and the statement of this question is: for a laboratory assignment, if the equipment is working, the density function of the observed outcome x is basically given by this density function, which is f of x equal to 2, 1 minus x for the values of x greater than 0 and less than 1 and 0 elsewhere. Okay, find the variance and standard deviation of x. Okay, so as we have seen in our previous question, we can write the solution here, that in previous question we have seen that the variance of any variable x can be found out by finding the expected value of the x square and subtracting from it the square of the expected value. Okay, so this is the main formula or main equation which we have been using since our previous question. Okay, and this is also very important because this is the easiest way to find out the variance, and once when we will find out the variance, the square root of this variance would be the standard deviation. Okay, so let us first find out the value of E of x. Okay, so as we can see that this is a continuous random variable, so therefore in order to find the value of the expected value here, the random variable here is x, the density function of it is f of x, so we have to integrate it within the limits with which this is given, so it is from 0 to 1. Okay, so let me find the values here. Okay, so it is from 0 to 1, the value here is x, and the value of f of x is 2, 1 minus x, and this is d of x. Okay, so this 2 is constant, this is 0 to 1, this would become what? X 1 minus x d of x. Okay, also here it would be 2, and it would also be 0 to 1. Okay, and here it would become x minus x square d of x. Okay, let me continue it here. This would be here, so here it would become e of x is 2. Let me close it here. So it would become, taking the integral of all the values here, we would get 0 to 1 x of dx, and also here minus 0 to 1 x square d of x. Okay, also 2, the integral of x would be x square divided by 2, and it is from 0 to 1, minus the integral of x square is x cube divided by 3, 0 to 1. Okay, so we would get here 2. Putting these limits here, which is very easy, we can find out here 1 by 2 minus 1 by 3. Okay, so here e of x would be 2. Taking the LCM of it, we would get 6. Okay, 1 by 2 multiplied by 6 is 3, minus 3, 6 multiplied by 1 by 3 is 2. It would be 2 multiplied by 1 by 6, which would be what? Which would be 1 by 3, and that is what? That is for the expected value of x. Okay, so we have found out that the expected value of x is here. Similarly, now let us find out the value of e of x square. Let me move down somehow, and the value of e of x square would be what? The same formulation, just we have to do what? Here we have to write x square. Okay, so writing x square here, and all the formulation would be the similar ones. So here writing x square and then integrating them all just like here. So let me use this one here. Okay, so let me use this one here. Instead of this x, we have to write x square. So what would we get here? This 2 will be here. It would be x square and 1 minus x d of x. Okay, so I hope you have understood that why I have written here x square instead of x, because here it was first x of x, f of x. Now in order to find out the value of ex square, we have here from 0 to 1 x square f of x dx. Okay, so therefore simplifying it, we will ultimately get this one. Okay, so now it would be 2, 0 to 1 x square minus x cube d of x. Okay, or taking the integral of both of them, okay, because this is the linear operation. So we would get what? It would be x cubed divided by 3 from 0 to 1 minus x4 divided by 4 from 0 to 1, okay. Similarly here we would get, putting these limits here, it would become 1 by 3 minus 1 by 4, okay. So 2, taking the LCM, it would be 12. So 12 multiplied by 1 by 3. So we would get here 4 minus 3 here. Okay. So 2 multiplied by 1 by 12, which will ultimately be what? Let me move down somehow here as well. So it would be 1 by 6, and this is what? E of x square. Okay. So that is for the E of x square. Now we have the values of E of x square and E of x. Let me put them all here, okay, in this equation. Let me use this green color for it. So the variance of x would be, E of x square is what? This is 1 by 6. Okay, let me confirm it. Yeah, this is 1 by 6. So this is 1 by 6 minus E of x is 1 by 3. So the square of it here. Okay. So here 1 by 6 minus 1 by 9. Okay. So ultimately the answer of it would be what? So the answer of it would be 1 over 18, which we can check ourselves as well. Okay. So I have calculated it and given you the answer of it. Okay. So this is the variance. In order to find out the standard deviation, this is the standard deviation. So standard deviation is the square root of the variance. So therefore it would be the square root of 1 by 18, because 1 by 18 is the value of the variance. So finding it out, what would we get? It would be 0.236. Okay, and that is what? That is for the standard deviation. So that's it for today, in which we have seen the standard deviation and variance calculation for the continuous random variable. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.51 of chapter 4. So the statement of this question is, for the random variable x and y in exercise 3.39 on page 105, determine the correlation coefficient between x and y. Okay, so today we are going to find out the correlation coefficient. Previously, what we have done, we have found out the covariance. And what was basically the covariance? First, we had found out the expected value of x and y, which is the combined expected value. And from them, we have subtracted what? We have subtracted the expected value of x multiplied by the expected value of y. Okay, so this is what? This is the covariance, and it strongly depends upon the units of these quantities. Okay, so this is a unit full quantity. In order to make a unitless quantity, what we have here? We have here the correlation coefficient, and correlation coefficient is basically the normalized version of the covariance. Okay, so in order to find out the correlation coefficient, what do we have to do? We have the covariance, and the same covariance we have to divide it over the variance of x and variance of y and the whole square root of it. So this is the correlation coefficient. Okay, so in this way we can also write this correlation coefficient. Let me write it CC. We can also write it like E of xy minus E of x and E of y divided by the sigma x sigma y. Also here it will be the whole square root. So here what? It is basically the equation we will be needing in our question. Okay. So if we have this value, if we have these two values, and if we have the variances of the both the random variables, we can very easily find out the correlation coefficient. In our previous questions, we have already found out the marginal distribution for x and y, and also the expected value of xy, expected value of x, and expected value of y as well in our previous question. Let us move to those questions, see that what were those. So this was basically question 4.44, in which we had already found out the values of fxy, and on the basis of the values of x and y, we have calculated the values for e of xy. Okay, let me move down somehow for the other values. We have already found out the mu x, which is basically e of x, and also e of y. Okay, these values are already given. Also, this was basically the function we had, and I will put a link of this question over here as well. So this was basically the equation for the joint probability distribution, and on the basis of it we had found out the values which are here. So then after it I had found out what this is basically the formula for the covariance. Okay, so finding here the covariance, what was the value? So here the value of the covariance was this one. Okay, so the covariance here was sigma xy. So this was minus 3/14. So let me go back to our today's question. So in solving the question, the value of sigma xy or covariance, this was sigma xy, and it was already given, which was minus 3/14. Now in order to use this equation and finding the value of sigma x and sigma y, what do we have to do? We have to use the same equation which we had there, and it was what? It was writing all the values of x here, and here x square f of x, and here y square f of x. Okay, so these are the values here. So let me move back to the question which I was previously referring. So now here, in order to find out the values here, what would we do? We will just write here what? Here it would become sigma of x equal to x square f of xy, and for sigma of y I will have here x y square f of xy. Okay, just writing all the values here just by squaring the terms here. Okay, and also here what would we get? We have calculated it, and the values of them were, it was 15/28, and this was 3/7. Okay, let me move back to my question. So this was what? This was basically 15/28, and this was 3/7. Let me write these values over here. So we will have here the correlation coefficient equal to the minus 3/14 divided by the square root of what? 15/28 multiplied by 3/7. Okay, so it would be minus 3/14 multiplied by 1 over, all of it will become 45 divided by 196, because 28 multiplied by 7 is 196. Okay, so writing them here, we can also write here minus 3/14 multiplied by 1 over, it would become 5 multiplied by 9 divided by this is 14 square. Okay, so let me move down somehow. Here it would become the coefficient. This would be minus 3 over 14 multiplied by 1 over, this is basically the square root of 9 is 3. So 3, and here we would get 5. Also here this is 14 square, so it will become 1 and it is now 14. So these two will cancel out, and ultimately here I will get minus 1 over square root of 5. Okay, so this is what, this is basically the correlation coefficient of the question which we had to do, and that is basically the solution of our question 4.51. Okay, so if you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 4.52, and the statement of this question is random variables x and y follow a joint distribution which is given by this formula, according to which fx of y is equal to 0 for the ranges which are given here. Okay, so these are basically the ranges of x and y, and 0 otherwise. Okay, so on the basis of this joint distribution formula, we have to determine the correlation coefficient between x and y. Okay, so what is this? This is basically the statement of the question, and in order to find the correlation coefficient, we have previously seen that the formula for the correlation coefficient is, let me write it here, this is equal to E of xy minus E of x E of y whole divided by the square root of the variance of x multiplied by the variance of y. Okay, so this is the formula we have to use here, and here we can very clearly see that these terms, which is here, and here, okay, these terms are unknown. So first of all, we have to find out these terms. Let me first find out the value of E xy. Okay, so in order to find it out, we can very clearly see here that we have here these x and y. Okay, so we have to take the double integral, and in order to write the double integral here, we have to, as this is the expected value, we have to write the values of x and y, and with it I have to multiply xy. Okay, so the first integral here would be of d of x, and the second one here would be of d of y. Okay, so in order to find it out, this will be the integral for x. Okay, and after it, after when we will find it out, we will have to find out the overall integral. So let me write out the values of these integrals. So let me write it out. This is for x. Okay, and the ranges for x are what? This range for x is from 0 to y. So the lower range here is 0, the upper range is y. Okay, similarly for y, what are the ranges? We can see that these are the ranges from 0 to 1, so it would be from 0 to 1, because these are basically the higher ranges, and within this limit the overall joint distribution function lies. Okay, so therefore the higher limit basically lies from the higher limits. Okay, so higher integral is within the higher limits. So let me find it out. It would be 0 to 1. Okay, and here x y 0 to y, sorry, let me write it again, and here 0 to y x y, and the value of f of x y is 2. Okay, so multiplied by 2 d of x, and with it d of y. So here it would be 0 to 1. Okay, 2 would be the common here, and here it would be from 0 to y x y d of x. Okay, d of y, and also here let me move down somehow. Here it would be from 0 to 1. Here y will also be the constant because it is the integration with respect to x. So 2y 0 to y x dx, here it would be here dy, and 0 to 1 2y, this would become x square divided by 2 from 0 to y, okay, and dy. Here you can see that this 2 will be cancelled out with this one. Let me move down somehow as well. Okay, so here we would get what? Putting these limits here, what I will get, it would be from 0 to 1. Putting it here, we will get y into y square dy, which will be ultimately 0 to 1 y cube dy, okay, which will be y4 divided by 4, 0 to 1, and ultimately it will be what? It will be 1 by 4. So the value of exy is 1 by 4. Okay, so let me highlight it. This would be 1 by 4. Let me move to the other values here. So the other values here, this one is known. Now let me move to the other values which are here, e of x, e of y. Okay, so let me find out the value of e of x. So the value of e of x is for what? It will be for x g of x, okay, d of x. Okay, so the values of e of x would be what? These must be the limits here, but here you have to keep in your mind that this g of x is basically the marginal distribution, which we don't know. Okay, so in order to find the value of g of x, what do we have to do? Let me write them here. So g of x would be the integral of what? It will be the integral of x of y, okay, with respect to what? With respect to y. Why? Because this is the marginal distribution for x, and all the values of x will remain the same while the values of y will change, as we have seen in our questions related to what? Related to the tabular forms. Okay, so this is what we will have. Also we can see from here that the ranges of y are from what? These are from x to 1, so therefore here it would be x to 1. Okay, so let me write these values of them. So here fx of y, the value of it is 2, so let me write it here, x1 2 dy. Okay, or here let me take it outside because this is a constant, x y dy, which will ultimately give me 2y x1. Okay, so let me move down somehow, and here it would become 2 1 minus x. Okay, so this is what? This is for g of x. So this is the value of g of x which we have found out. In order to find the value of e of x, now we have to put it here. Okay, so let me put it here and see that what will be the answer. So in order to put it here, we will get what? The expected value of x would become what? Integral from x multiplied by 2 1 minus x with respect to d of x. Okay, so in order to write the limits here, what do we have to do? Here we can see that the overall limit for the functions here are from 0 to 1, so therefore x will be from 0 to 1. Okay, so finding them out here, it would be from 0 to 1. Okay, so let me write them here. It will be 2 outside, and also inside of it we will have x multiplied by 1 minus x and d of x. Okay, so let me calculate it, and here it would become 2 integral of 0 to 1 x dx minus 0 to 1 x square d of x. Okay, so now finding it out, it would become 2. Here it would be x square divided by 2, 0 to 1 minus x cube divided by 3, 0 to 1. Okay, so ultimately the expected value of x, what would we get, would be 1 by 3. Okay, so that is what, that is for the expected value of x. Now let us move to find the other values here, and here it is expected value of y. In order to find it out, what do we have to do? Let me separate it out here. So the expected value of y here would be what? Here it would be the integral from 0 to 1, because this is the overall value here. Okay, and that is the averaging. And also here y and h of y dy. What is this? This is basically the, what is this? This is again basically the marginal distribution, which we don't know here. So let me first find out the value of h of y. So here it is again for x y, while here the integration will be in terms of x. Okay, because of the same reason I have previously described. Okay, and now let us write the limits for x. So we can very clearly see that the limits of x are from 0 to y. So therefore it would be from 0 to y. Let me write them here. So this is fx of y. So this is 2. Let me put it out of here. It would be from 0 to y d of x. Okay, 2 multiplied by x, 0 to y. Okay, so ultimately it would be 2y. So the value of h of y is 2y, and this is what, this is the marginal distribution. Let me take it and put it here. So putting it here and solving it, what would I get? Okay, here I would get e of y, writing the limit 0 to 1. Okay, y into 2y and dy. Okay, so 2 and 0 to 1 y square d of y, it would be 2 multiplied by y cube divided by 3. Okay, so it would be from 0 to 1. So ultimately we would get what? The answer of it would be 2 by 3, and it is the expected value of y. We have found out the expected value of x, expected value of y, and all those values. Similarly, the remaining values here are variance of x and variance of y. In previous questions, we have clearly seen the formula for finding the variance, and this was what? This was basically the expected value of x square minus expected value of x whole square. Okay. Similarly, for the variance of y, it would be what? It would be the expected value of y square minus the expected value of y whole square. Okay, so once you will calculate them, what would you get? The answer of them would be what? It would be 1 over 18, and it would be 1 over 18 as well. Why? Because you have to calculate the value of e of x square. The same will be followed here. Okay, as we have done here, just we have to use what here in order to find the square term. What would we have? Let me use this color for it. If you want to do this one, you have to square it, square it, square it. You would get here e of x square equal to 1 by 6, and also for e of y square some value. Okay, you have to put those values here because you already know the expected value of x, expected value of y, and from them you would get these values. Okay, taking these values, as you know that all these values are now given, putting them all there. So let me put them all there. So putting all these values here, the correlation coefficient will become what? Ex of y is what? That is 1 by 4 minus e of x is 1 by 3, e of y is 2 by 3, whole divided by the square root of 1 by 18 multiplied by 1 by 18. Okay, solving them, so ultimately you will get what? You will get 1 by 2. Okay, so that is what? That is the correlation coefficient which we wanted to find out. Okay, so I hope you have understood all the underlying steps which we have taken here. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.53, and the statement of this question is referring to exercise 4.35 on page 127. Find the mean and variance of the discrete random variable z equal to 3x minus 2. Okay, so let me underline it. Z is 3x minus 2 when x represents the number of errors per 100 lines of code. Okay, so this is the statement, and the original question 4.35 is here. The statement of it was the random variable x representing the number of errors per 100 lines of software code has the following probability distribution, which is given here. So by using theorem 4.2 on page 121, we had to find the variance of x. Okay, so to find the variance and mean of all that, first we have to go through our question, which is here. Here we have to find what? We have basically to find the mean and variance of it. Okay, so first we have to find the mean of z, which is here. So z is what do we have to find? Actually, this is e of 3x minus 2. Okay, so ultimately it would be what? It would be e of 3x minus e of 2 because of the linear property of this averaging. Okay, or separating it out, this 3 will be outside of it. Here it would be x, and the mean of this 2 is also 2. Okay, so this is what we have here. Okay, so here in order to find the values here, the e of z would be what? It would be here 3 e of x minus 2, while the variance of z would be what? We can see here that the mean here is multiplied by 3, and it is only affected by the multiplication term, which is the square root of this. So therefore it would be this multiplicative term square multiplied by the variance of the original random variable. Okay, so these are basically the two formulas which we have to use. Okay, let me call it A, and this is the second one. Okay, let me call it B. What is missing here? We can very clearly see that the missing terms here are e of x and sigma square of x, which are here. Okay, which must be known from this table. Okay, so let me find out these values. In order to find the value of e of x, what do we have to do? We have to multiply each terms here with the corresponding density function. Okay, so it would be what? It would be the summation of x of I with the corresponding f of xi. Okay, let me multiply these terms here. So multiplying them here, it would be these two will be multiplied, these two, these two, these two, and these two. Okay, so let me multiply them. It would be 2 multiplied by 0.01
plus 3 multiplied by 0.25, because this one here is x1 and this is f of x1. Similarly, this is x2 and this is f of x2 and so on. Okay, so let me continue it. Let me remove them first. So it would be 4 multiplied by 0.4 plus 5 multiplied by 0.3 plus 6 multiplied by 0.04. Okay, so multiplying them all together, what will we get? The answer of it or the mean of it would be 4.11. so this is what the expected value of x. Okay, so this is what? This is 4.11. Now in order to find the value of the variance of the x or sigma square of x, it would be what? It would be the e of x square minus e of x whole square. We know the value of e of x, which is known here. We don't know the value of e of x square. In order to find out the value of e of x square, what do we have to do? We will have to use the same formulation, and it would be summation of all and squaring the x term, multiplying it with the x of I. So I will get here 2 square multiplied by 0.01 plus 3 square multiplied by 0.25 plus 4 square multiplied by 0.4 plus 5 square multiplied by 0.3 plus 6 square multiplied by 0.04. Okay, so let me find out its value. When you will find out the value of it and when you will put it here, so the value of it would be here. The value of e of x is 4.11 whole square. So after putting these values here, the answer of it would be what? It would be 0.74. Okay, so this is for the variance of it. Now in order to take these values and putting them here in equation A and B, let me move down somehow. So putting them here, let me put them here, and the expected value of z would be what? It would be 3 multiplied by e of x. So e of x is 4.11 and minus 2. Okay, multiplying them and then finding the answer of it, it would be 10.33. This is what? This is the answer for expected value of z. Now in order to find the variance of the z, I have told you that it would be 3 square multiplied by the sigma square x. Okay, so 3 square is 9 multiplied by the sigma square of x, which is here or here, so it is 0.74. okay, so finding it out and then its value would be 6.66, and that is what? That is the solution for question 4.53. and you have seen that how can we find out the scaled versions of the random variable, its mean, its variance, and all the other statistical quantities from it. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. Question 4.54, and the statement of this question is: using the theorem 4.5 and corollary 4.6, find the mean and variance of the random variable z equal to 5x plus 3, where x has the probability distribution of exercise 4.36. okay, on page 127. So here we have already solved the question 4.36, and from it we have seen this, that the expected value of x was 1 and also the variance of x was also 1. okay, so this was what we had previously found out from that question. Okay, so now as we have done previously here, in order to find the expected value of z, it would be the expected value of 5x plus 3, or it would be the expected value of 5x plus expected value of 3 because of the linear nature of this expected value, or this multiplicative term will be the outside of multiplication with the expected value, so it would become expected value of x plus this expected value of 3 is already 3, so expected value of z would be what? It would be given here. Okay, also the variance of it would only depend upon the multiplicative term, and the variance of this z would be what? It would be the square of this multiplicative term multiplied by the variance of the original random variable. Okay, in order to find it out, let me find out the expected value of z. We already know the expected value of x, which is 1. Let me put them here. So it would be 5 multiplied by 1 plus 3, so it would be 8, and also variance of z, it would be what? It would be the 25 multiplied by the sigma square, which is 1, so it would be the 25. Okay, so this is what? This is basically the answers of our question 5.54. If you have any question regarding them, that how to find them out from these formulas, you can ask me in the comment box. Okay, so take care of yourself and I will see you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.55, and the statement of this question is, suppose that a grocery store purchases 5 cartons of skim milk at the wholesale price of $1.20 per carton and retails the milk at $1.65 per carton. After the expiration date, the unsold milk is removed from the shelf and the grocer receives a credit from the distributor equal to the 3/4 of the wholesale price. Okay, so what is basically the wholesale price? It is this one. If the probability distribution of the random variable x, the number of cartons that are sold from this lot is here, this is the probability distribution for the number of cartons, which is x. We have to find the expected profit. Okay, so now in order to solve this question, what do we have to do? Here x is what? X is basically the number of cartons. Okay, so now in order to find the profit here, what do we have to do? First, we have to find out all the expenditures and also the profits which a person has got. Okay, so we have to subtract the expenditures from the profit he got. Okay, so the first expenditure is that of this buying. Okay, so he has bought 5 cartons of skim milk at the wholesale price of 1.20 per carton. Okay, so the expenditure on cartons is how much? That is basically the number of cartons, which are 5, and each carton is of $1.20. Okay, so it will give us what? It will give us $6. Okay, so the $6 is the expenditure on cartons. Similarly, after the expiration date, the unsold milk is removed from the shelf and grocer receives a credit from the distributor equal to the 3/4 of the wholesale price. Okay, so money back after expiry, this is what? This is 3/4 of the wholesale price. So 3/4 multiplied by the wholesale price, which is 1.20. Okay, so it would be $0.90. Okay, so this is what we have here. Also, the profit he will get from the per carton. Okay, this is 1.65. Okay, so on the x number of cartons, the profit he will have, profit from cartons, he will have here what? X, which are the number of cartons, multiplied by what? It has to be multiplied with the amount of each carton, and that is 1.65. Okay, so x
multiplied by 165 is the amount here. Okay, so now in order to find the total profit here, or let me call it the profit P, this profit is equal to what? Profit from cartons, okay, which is here, plus money back after expiry, money back after expiry from X number of cartons, which will be different than this one. Okay, I will show you how is it different, and we have to subtract this amount. Okay, from this amount I have to subtract the expenditure on cartons. Okay, so that is already known, that is $6. Let me put all these values. So profit from cartons is what? This is 165 multiplied by X. Okay, similarly with it I have to add what? Money back after expiry from X. So each carton is giving us this $0.90. So therefore this would be the 0.90. so we will have 5 cartons. So out of 5, the remaining amount will be multiplied with this one, and it will be what? It will be the amount we will get. Okay, and also the expenditure here is minus the expenditure which is known, and that is $6. Okay, so let me write it here, 6. Okay, so let me calculate it, and this is a equation we have simplify. So it would be 1.65x, okay, multiplying this inside of it. Okay, so it would be 0.90 multiplied by 5, so it would be 4.5 minus 0.90x, okay, and also minus 6. Okay, so let me find it out. It would be 1.65 minus 0.90, it would be 0.75x. okay, also it would be 4.5 minus 6, it would be 1.5. okay, so this is the value for P. Now let me move down somehow. Okay, so this is what? This is basically the number of cartons here. Now in order to find them out here, the profit, if the number of cartons here is 1, putting here 1, we will get the profit, 2, we will get here the profit, and whatsoever. But here we have to find the expected profit. Okay, we have to find the expected profit for which this X should be the expected value of X. Okay, so therefore in order to find out the expected value of P, it would be what? It would be 0.75 multiplied by the expected value of X minus 1.5, and that is what? That is the equation which we are going to follow here. Okay, let me correct it. Okay, so this is what we have here. Now in order to find the value of E of X, we have to do what? We have to use this formulation in which this is X, this is f of X, and it would be what? Multiplying each term here with the corresponding density function, we will get 0 multiplied by 1 over 15 plus 1 multiplied by 2 over 15 plus 2 multiplied by 2 over 15, okay, 3 multiplied by 3 over 15, 4 multiplied by 4 over 15 plus 5 multiplied by 3 over 15. Okay, so from here we will get the expected value. So calculating it, what I will get here, it will become 2 over 15 plus 4 over 15 plus 9 over 15 plus 16 over 15 plus 15 over 15. Let me move down somehow, and here the expected value of x would be what? It would be 2 plus 4, 6, 6 plus 9, 15, 15, 15, 30. So it would be 46 over 15. Okay, so this is the expected value of x. Let me take it and put it here. Okay, let me use another color for it. This color. Let me take it and put it here. What would we get? The expected value of profit would become 0.75 multiplied by 46 over 15 minus 1.5. Okay, so calculating it, what would we get? It would be 0.80 dollars, and that is what? That is basically the solution of our question. Okay, so you have seen that how to find out the expected value of profit from the number of expenditure, from the number of profits, and the return quantities. Okay, so that's what we have solved here in this question 4.55. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 2.56, and the statement of this question is repeat exercise 4.43 on page 127 by applying theorem 4.5 and corollary 4.6. Okay, so in that question, what was given? Let me write it here. So using the color here and here, the question here was f of x is equal to 1 by 4 exponential of minus x by 4 for x greater than 0, and it is 0 elsewhere. Okay, so this is what we have. Now in order to see the theorem 4.5, what was it? So in order to find the expected value of ax plus b, it would be what? It would be a expected value of x plus b. Okay, similarly, according to this corollary, the variance of ax plus b is what? This is equal to the a square sigma square of x. Okay, so these are the two things which we have to remember here. So according to our previous question, what did we have to find out? In that question, we had to find out the expected value of y. Okay, where y was what? Y was basically the 3x minus 2. So therefore, we had to find out the expected value of 3x minus 2, which will be, according to this, would be what? This would be 3 expected value of x minus 2. Okay, so that is what we have to find out, and here let me call it equation A. Okay, so the expected value which is here, in order to find it out, we had to do what? The expected value of x is basically x f of x dx. Okay, and here we have to write the limits. So as the limits are from 0 to infinity, so here we have to write them here. Okay, now let me write their values, or using the color which is black here, let me use this color. So in order to find the expected value of x here, what do we have to do? Let me write the value of f of x, and this x is basically this capital X. So it would be 0 to infinity x. F of x is 1 by 4 exponential of minus x by 4 d of x. Okay, so this is what? This is the multiplication, and here we have to use the integration by parts. Okay, so applying the integration by parts here, let me use here the formulation. Here, according to that formulation, let me take this one as u and this one as dv. Okay, so according to that one, or integration by part, what would we have? We will have u dv equal to
uv minus integral of v du. Okay, so we have to use these one here. Okay, so we have these values. We know the value of u, which is given here, and that is x. Okay, so on the basis of it, the value of d of u would be d of x. Okay, similarly, we know the value of dv, but here this is basically the constant term, so let me take it out. So here it will be here, okay, and the original dv will be here. So it would be what? It would be exponential of minus x by 4 dx. Okay, so on the basis of it, integrating both sides, what would we get? The value of v would be minus 4 exponential of minus x by 4. Okay, so that is what, these are basically the values we will need in our upcoming valuation by putting them all here. Okay, so let me put them here and see that what happens. Okay, so let me move down somehow, putting them all values here. Here we would have this common 1 by 4 and also this uv. So u is x while v is what? That is minus 4. Let me write it here, minus 4 e of minus x by 4. Okay, and as this is the definite integral, we have to write here from 0 to infinity. Okay, with it I have to subtract, and there I have to this integrals. This would also be from 0 to infinity. The value of v here is also given, and that is minus 4 exponential of minus x by 4. Okay, and with it du, so du is also given, and that is d of x. Okay, so let me simplify it. Simplifying it, what I will get here, it will be this would be minus 4 multiplied by x exponential of minus x by 4. This will be from 0 to infinity. Also here, integrating this one, what would I get here? The answer of it would be, this would be the 16 exponential of minus x by 4. Okay, and it would be from 0 to infinity. Okay, so these are here. Now writing them here, what will I get here? Putting this limit here, this would become 0 0. Why? Because here it would be 1 by 4. Okay, and it would be minus 4, so it would be 0 0, so it will be 0 here as well, and also here minus 16, and here writing these limits here, we would get 0 minus 1. Okay, which will ultimately give me 1 by 4 multiplied by 16. So the answer of it would be 4. Okay, so the expected value of the x is 4. Okay, now taking this value, which is equal to 4, okay, and putting it in equation which is given here. So let me see, where is that? This one is, let me see that. Yes, it is here. Okay, so let me take this 4 and put it here. So here in this one, the expected value of y would be the 3 multiplied by the value of it is given, that is 4 minus 2. So the answer of it would be 10, and that is what? That is basically the solution for finding the expected value. Okay, also to find the variance of it, let me see that what is this. So in order to find the variance of my question, we have here this formula. So this one is here, and in order to find it out, we have to find the sigma x square. Okay, so in order to find it out, what do we have to do? Let me start doing it here, and to find it out, what would we get? Sigma x square is equal to the expected value of x square minus the expected value of x whole square. Okay, so its value is already given, and that is 4. While to find out the value of it, what do we have to do? We have to use the same formula, but here if I will use here square, I have to use here square as well, and again the same formulation whatsoever we have done here, we again have to use the integration by parts and all steps again. Okay, so finding them all, the answer of it is given, and that is 32. Okay, so putting the value of e of x here, we would get here 16. Okay, so ultimately the answer of sigma x square is 16. Now in order to find the value which is here, okay, so in order to find the value of this one, let me use this color. So this would be the sigma square 3x minus 2, because this one is here and this is because of this y. So this would be, the a here is 3. So 3 square multiplied by sigma square x, this is 16 multiplied by 16. Okay, so 3 3 9, 9 multiplied by 16. So this is what? This is basically 144, and that is what? That is the solution for the variance of my question. Okay, so that's it for today, in which we have seen and found out the expected value of y and also the variance for my question as well. So that is basically the solution, in which we have discussed all of these quantities one by one. Okay, so if you have any question, you can ask me in the comment box. So see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.57 of chapter 4, and the statement of this question is, let x be a random variable with the following probability distribution. For all the values of x, the value of f of x, which is the probability density function, has been written here as well. So on the basis of this table, what do we have to do? We have to find the e of x, expected value of x, and e of x square, and then using these values we have to evaluate the value of e of 2x plus 1 whole square. Okay, so that is what we have to do today. In order to do so, let me solve it here. This is the solution. Okay, and in solving it, let us find here the value of e of 2x plus 1 whole square. Okay, we have to find it out. In order to find it out, let me first open this bracket and see what would it be. So it would be 2x whole square plus 2x 1 plus 1 whole square. Okay, so it is why, because we have a formula that a plus b whole square is equal to a square plus 2ab plus b square. Okay, so we have this formula. So on the basis of it, we have to evaluate it. So evaluating it and then finding it out, from here we would get 4x square, here we would have 4x, and here we would have 1. Okay, so using the previously obtained formulation of the expected value, from that we will very easily see that it would be what? It will be the 4 e of x square plus 4 e of x, and here expected value of 1, it will be 1. Okay, so this is what? This is the formula we have to use here, and let me first underline it and keep it here as well. Okay, so now in order to do so, what do we have to do? We have to find the value of e of x square and then e of x. Okay, so these are basically the two values we have to find here. Okay, so to find out the value of E of x here, what do we have to do? These are basically the discrete values. So in order to do so, we have to sum them from 1 up to n, okay, and all these values will be E of x of I and f of x of I, okay. So here I basically ranges from 1 to 3, okay, 1 to 3, these are the values. So let me write them here. Here we will have x1 f of x1 plus x2 multiplied by f of x2 plus x3 f of x3. Okay, let me write their values. So x1 is minus 3 multiplied by f of x1, which is 1 by 6, plus x2 is 6 multiplied by 1 by 2, okay, plus x3 is 9 multiplied by 1 by 3. Okay, so from here we will get minus 1 by 2 plus 3 plus 3. Okay, so evaluating it, we would get what? Here the answer of it would be 5.5, and that is for E of x. Okay, now for E of x square, what do we have to do for E of x square? Let me evaluate it here. For E of x square, the formula which is here would become what? It would be from 1 to n, and here the value of xi would be square and all other xi will remain the same. Okay, so using the same formulation, we will have here minus 3 square multiplied by 1 by 6 plus 6 square multiplied by 1 by 2 plus 9 square multiplied by 1 by 3. Okay, so evaluating it at the end, we would get what? The value of it would be 46.5, and this is for E of x square. Okay, so we know the value of E of x. Here it is. Let me put it here, and the value of E of x square, let me put it here as well. So let me put these values here and use this color for it. We would get 4 multiplied by what? 4 multiplied by E of x square, and this is 46.5 plus 4 multiplied by 5.5 plus 1. Okay, so evaluating it at the end, we would get 209, and that is what? That is basically the solution of the question we have. So the answer of it is 209. Okay, so we have obtained the value of E of x, which is here. We have obtained the value of E of x square, which is here, and for this we have also obtained the value which is here by using the formulation which we have. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.58, and the statement of this question is the total time measured in units of 100 hours that a teenager runs her hair dryer over a period of 1 year is a continuous random variable x that has the density function, which has been written here as f of x equal to x for the range of x greater than 0 and less than 1. Similarly, it is 2 minus x for the range x is greater or equal to 1 and less than 2 and 0 elsewhere. Okay, so we have to use theorem 4.6 to evaluate the mean of the random variable y equal to 60x square plus 39x, where y is equal to the number of kilowatt hours expended annually. Okay, so now here we have this transformed random variable, and here to find the values of it, let me solve it here.
the solution of it would be started from here. So here, to find the expected value of y, we have to do what? We have to do expected of y is 60x square plus 39x. Okay, so this is what we want to find out. In order to use the previous theorems, what would we get from it? We would get 60 expected of x square plus 39 expected value of x. Okay, so this is the formula for finding the expected value of y, and this is what we will utilize here. Okay, so this is the formula which will be utilized here. Now, in order to find it out, what are the required things which we want to find here? The required items here are e of x square and e of x. So let me write them here. Okay, so writing them here, what would we get? The expected value of x equal to something and expected value of x square. Okay, so now in order to find them out here, it would be what? It would be the integration from certain limit, which is from 0 to 2, because within this limit all these values are known, and out of this limit the value is 0. Okay, so let me use it, and it would be from 0 to 2 x of f of x dx. Okay, and for e of x square we would have what? It would be the similar one, 0 to 2 x square f of x d of x. Okay, so let me put all these values, but before putting the values, we know that for the range of 0 to 1 the value is x, and for the range from 1 to 2 it is 2 minus x. Let me put these ranges here, and it would become what? From 0 to 1 it would be x multiplied by f of x, and the value of x, f of x is x, and d of x. Okay, similarly 0 1 to 2 it would be x multiplied by 2 minus x d of x. Okay, so this is for expected value of x. Let me find it out first, and then we will go to ex square. Okay, so here it would become 0 to 1 x square d of x plus 1 to 2, and multiplying it inside, what would I get? It would be 2x minus x square. Okay, this is the overall, and d of x. Okay, let me move down somehow. So here we would get what? It would be from 0 to 1. So let me first simplify them, and then I will evaluate them by using the integration. And similarly here it would become 1 to 2 2x d of x minus 1 to 2 x square d of x. So here, finding the integral of each of them, we would get x cubed divided by 3 from 0 to 1. Okay, here it would be 2 into x square divided by 2 from 1 to 2, and minus it would be x cubed divided by 3 1 to 2. These two will cancel out. Okay, and here out of all of them we would get what? Let me move down somehow. Okay, so here it would be, putting limit here, I will get here 1 by 3 plus putting limit here, what I will get? It will be 2 square minus 1 square, so it will be 3 minus it will be 1 by 3 and multiplying it 8 minus 1 is 7. Okay, putting all these values here, it would become 1 by 3 and all this, the LCM of it is 3. Here I will get 1 plus 3, 9 and here we will have 7. Okay, so it would become what? It would become 1 plus 9 is 10 minus 3, though this would be 3 by 3. So ultimately it would become 1. So the value of E of x is what? This is found to be 1. Okay. Now after it, let me separate out it. Okay, so this is separated out. In order to find the value of E of x square, let me move it here. Okay, so it would be what? E of x square is equal to 0 to 2. Again, the values of it are from 0 to 1. It is what? It is f of x is x, d of x, and also from 1 to 2, this is the x square which is here, and the value of f of x is 2 minus x dx. Okay, so after solving it like we did previously, it is 0 to 1 x cube d of x plus 1 to 2, it would become what? It would be 2x square d of x minus 1 to 2 x cube d of x. Okay, or ultimately we would get x of 4 divided by 4, 0 to 1 plus 2 multiplied by x cube divided by 3. It would be from 1 to 2 minus x4 divided by 4 from 1 to 2. Okay, so solving it out, putting all those values, what would I get? The answer of it would be 7 by 6, which is the value for E of x square. Okay, so this is what? This is the value for the E of x square. Let me underline it, and these are the values which are known. So now let us take them and put them inside our main formula. So the main formula is here, which is this one. So let me take these values and putting the values here. So 60 multiplied by E of x square is 7 by 6. Okay, plus 39 multiplied by 1. Okay, so it would be 60, 10. So the answer of it would be expected value of y would become 70 plus 39. So it is 109, which is the answer of the question which I was doing, and this is what? This is the value of E of y. Okay, so that's it for today, in which we have solved question 4.58, and here we have seen that how to formulate the strategy to find out the expected value of the transformed variable in the continuous random variable. So if you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.59, and the statement of this question is, if a random variable x is defined such that E of x minus 1 whole square is equal to 10 and E of x minus 2 whole square is equal to 6, find mu and sigma square. Okay, where mu is basically the mean and sigma square is the standard deviation. So let me solve it first, and in solving it, first we have here two equations which are E of x minus 1 whole square equal to 10 and E of x minus 2 whole square
equal to 6. Okay, so as we have here these equations, okay, we have here these equations, so let me follow a very well known equation, which is a minus b whole square equal to a square minus 2ab plus b square. Okay, following it here, what would I get here? In both of these equations we will get x square minus 2x plus 1 equal to 10, and in the other equation I will get x square minus 4x plus 4, this is equal to 6 as well. Okay, now again formulating the strategy such that we have previously seen in our previous questions, that e of a x plus b, this is equal to what? This is equal to the multiplicative factor will be outside of this expected value of x, while the constant term will be same. It is applying the same formulation here. What would we get here? We would get expected value of x square minus 2 expected value of x, and expected value of 1 will be, as this is the constant, so it will become 1 as well, and here we will have 10. Similarly for this one, e of x square minus 4 e of x plus 4 here. Okay, and this is equal to 6. Okay, so now subtracting 1 from both sides of the first equation, we will get here e of x square minus 2e of x, this is equal to 9, and similarly in the other equation we will get e of x square minus 4 e of x, this is equal to 2. Why? Because of subtracting 4 from both sides. So let me here perform some substitution. So in that substitution, let me take e of x square equal to what? Let me call it p, and let me take e of x equal to q. Okay, so this is p and q, and putting them here, what would I get here? It would become p minus 2q equal to 9 and p minus 4q equal to 2. So let me call it equation A, and let me call it equation B. Okay, so now in order to find the values of p and q, what do we have to do? We have to, let me subtract equation B from equation A. So let me write them here. We will get here p minus 2q equal to 9 and p minus 4q equal to 2. Okay, so in subtraction the signs of them will change. It will become like this. So here these two will cancel out, and here it will come 2q equal to 7, or q will become 7 by 2. Okay, so this is what q is. Now in order to find the value of the other unknown variable, which is p, let me put the value of q in A. Let me take the value of q, put it here. So what would I get? It would become 2 multiplied by 7 by 2 equal to 9. Okay, these two will cancel out, and ultimately the value of p would become what? The value of p would become 16. Okay, so this is the value of q, this is the value of p. Okay, but here we have seen that p is basically e of x square and q is e of x. So let me put these values here. So p is 16 and q, which is e of x, that is 7 by 2. Okay, so this is basically the answer of ex square and e of x, while we can very clearly see that this is basically mu, which is the mean of the random variable we have here. So this is the mu. Now in order to find the value of the sigma square, we know that this is equal to e of x square minus mu square. Okay, let me put their values. So here e of x square is how much? This is known and this is 16. So 16 minus 7 by 2 is basically 3.5. So 3.5 square. Okay, so finding it out, it would become what? It would become 3.75. Okay, so the value of the standard deviation is also found out, and this is 3.75 and this is sigma square. Okay, so the value of mean is also found out here and the value of standard deviation is also here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 4.60 of chapter 4, and the statement of this question is: suppose that x and y are independent random variables having the joint probability distribution which has been written in the form of this table. So on the basis of this table, we have to find part A and part B of our question. Okay, so first of all, we have to see that what is this. So this is the joint probability distribution, but what we want to find out x and y, which are the marginal distributions. Okay, so marginal distributions are x and y, and these are the marginal distributions. Okay, so then after finding out the marginal distributions, we have to find out the expected value of them. Those would become e of x and e of y. So now here, in order to find the value of e of x and e of y here, what do we have to do? Let us see that this is for x and this is for x as well. So here, in order to find the value for, let me use the black color for it. Now in order to find the value of e of x, we have to take the value of x, which is 2, and with it I have to multiply all the relevant probabilities with that. Okay, so these are all the relevant probabilities with it, and I have to do what? I have to add them all together. Okay, so let me take them all. So these would be 0.10 plus 0.20 plus 0.10. Okay, similarly with it I have to add what? I have to add 4 and multiplying it with all the relevant probabilities it has, I have to take the sum of all of them. So what would it become? It would become 4 multiplied by 0.15 plus 0.30 plus 0.15 as well. Now let us do the calculation. It would become 0.40 plus, it would become 4 multiplied by what? It would be 0.60. Okay, because this is 0.15 plus 0.30 is 0.45 and this is 0.60. So it is here. Also here it would become 0.80 plus 2.40, and ultimately I will get 3.20, which is the expected value of x. Okay, so this is what we wanted to find out here, and this is the expected value of x. This is known now. Now in order to find out the value of expected value of y, let me take them here. So here let me use it here as well. So it would become expected value of y would become 1 multiplied by all the values, summation of all the values of them. So it would become 1 multiplied by 0.10 0.10 plus 0.15, okay, plus the other value which is 3. With 3 I have to multiply all the summation of all the relevant probabilities. So these are 0.20 and 0.30. So 0.20 plus 0.30 plus the third one is 5 multiplied by all the values of here. So 0.10 plus 0.15. So here it would become 1 multiplied by 0.25 plus 3 multiplied by 0.5 plus 5 multiplied by 0.25. Okay, so multiplying them together and then adding them, ultimately we would get here E of y equal to 3, and this is the value of what? This is the value of E of y. Okay, so that is known here. Let me use it here as well. Okay, so this is E of y. Now in order to find out the values of part A and part B, we have here E of 2x minus 2y, okay, using here the formula which is what? Which is the E of ax plus by. We would get what? It is equal to A of E of x plus B of E of y. Okay, using the same formulation here, what would I get? Here it would become 2 E of x minus 2, sorry, this is 3. This is 3 E of y. Putting their values here, the value of E of x is known, and that is 3.20. So 2 multiplied by 3.20 minus 3 multiplied by E of y, which is here 3. So this is 3 multiplied by 3. So what would I get here? It would become 6.40 minus 9. So the value of it would become minus 2.60. Okay, so that is what? That is basically the solution of part A of my question. Okay, so its solution is given and this is here. Now in order to find the solution of part B, let me move down somehow. Okay, so in order to find the solution of part B, which is E of x y, which is equal to what? Which is E of x multiplied by E of y. Okay, putting their values, so E of x is 3.20 multiplied by E of y, which is 3. So we would get, so it would become 9.60. Okay, so that is what? That is the solution of part B of our question. So that's it for today, in which we have seen the solution of question 4.60. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.61, and the statement of this question is use theorem 4.7 to evaluate E of 2xy square minus x square y for the joint probability distribution shown in table 3.1 on page 96. Okay, so this is table 3.1, and here we can see that we have all the values for x and y and their joint probability distribution here as well. Okay, so now in order to find the solution of this question, let me solve it here, and the equation we have here is 2xy square minus
x square of y. Okay, so let me apply the formulas here, and here in order to write the formulas at the end, what would we have? We would have here 2e of x y square minus e of x square y. Okay, so this is what you know, and this is because of the formulation where I have e of ax plus by. If we have this, so it will be a of ex plus b e of y. Okay, so this is because of this formula that we have got this one. Now here in this question, in order to find the values of this and this, what do we have to do? First of all, let me call it equation A. Okay, and from it, let me first find out the value of e of x of y square. Okay, so here e x of y square, it can be found out very easily by x on y square and the relevant f of x and y. Okay, so let me see them here. This is for all the values of x, this is for all the values of y. Okay, so this is the multiplication in, and if any one of them is 0, we will get here 0. Okay, so we can see that here all the values will be 0, because either here in this row we can see that all of them will be 0. In here we can see all of them will be 0 as well. Why? Because here y will be equal to 0, so multiplication here will become 0. Here x will be 0, so all of this will be cancelled out. This will also be cancelled out. Okay, similarly here we can see that here in these two values, this two here this x and y are non-zeros, while f of x y are zeros. Similarly here we can see that here this is also 0, so the only value which remains here is this 3 and 3 by 14, which is for x y equal to 1 and x equal to 1. Okay, so let me write those values here. So it will be for 1 square, and the value of f of x y will be 3 by 14. So it is what? This is 3 by 14 as well. Okay, similarly for finding the value of e of x square y, the similar operation will be followed here, because the multiplication will remain the same, because here we can see that it would be x square y. Okay, so this would be the same x y. Here we will have x square y f of x and y. Okay, so putting all the values just like it, we will get here 1 square multiplied by 1 multiplied by 3 by 14. So it will become, the answer of it will be 3 by 14. Okay, so these are what? These are the values of e of x square y and e of x y square. Let me put these values in equation A, and what would I get here? Ultimate equation I will get will be 2 multiplied by 3 over 14 minus 3 over 14. So the answer of it will be 3 over 14. So that is what? That is the answer of our question. Okay, so we have seen the solution of question 4.61. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.62 and 4.63, and today we are going to solve both of them, because that both of them are relevant with each other. So let us first solve question 4.62. If x and y are independent random variables with variances sigma x square is 5 and sigma y square is 3, while sigma x square is the variance for x and sigma subscript y square is basically the variance of y. We have to find the variance of the random variable which is composed of the combination of x and y, and that is equal to minus 2x plus 4y minus 3. Okay, so here
we have to keep in your mind that the two random variables are independent of each other. Okay, so this is the trick which we are going to utilize here in this question. So let us first solve it, and let me solve it here. Okay, so let us first see that if we have a random variable z equal to ax plus by plus c. So if I want to find out the variance of z, which would be the variance of ax plus by plus c, so this would be what? This would be a square multiplied by the variance of x plus b square multiplied by the variance of y. Okay, and also here we have to multiply with it 2a b and covariance of x and y. Okay, so this is the equation which we are going to follow in our question here. Okay, so this is what which we are going to follow. You have to keep in your mind that here this constant term has been reduced to 0 because it has nothing to do with the variance here. Okay, so this is the equation which we are going to follow here. So now if the two random variables are independent of each other, so in that case, if the two random variables are independent of each other, so it means the covariance or the relation in both of them is basically 0 because none of them is dependent upon the other one. So therefore in solution of the 4.62, I have to utilize this one, and putting it here, what would I do here? I would get here the variance of z is equal to what? This is equal to a square multiplied by the variance of x plus b square variance of y. Okay, while the other terms, because covariance is 0, so 2ab will also be 0, so therefore it would become 0 here. Let me put all these values here. So the value of a here is, in this z, is minus 2, so minus 2 whole square, and the variance of x is 5. Okay, here similarly b square is how much? That is 4 square, because this one is b, this is a, and also variance of y, this is sigma subscript y whole square, and that is 3, so multiplying it, it would be 3. So 2 to 4, 4 5 20, 4 4 16, and 16 3 48. Okay, so it would be what? It would be 68, and that is what? That is basically the solution for question 4.62. Okay, and that is what? That is the solution of this one. In question 4.63, what do we have to do? We have to repeat the same question if and x and y are not independent, means these are dependent upon each other, and the variance or the covariance between both of them is also given, that is sigma xy. Now let me utilize this equation here, and in utilizing it and putting all these values here when both of them are dependent upon each other, so this is 4.63. okay, this would be variance of z equal to, putting all these values as it is, so a square variance of x plus b square variance of y and plus 2ab multiplied by the covariance of x and y. Let me put all these values here. It would become minus 2 whole square, and variance of it is 5 plus 4 whole square, variance of y is 3, okay, as it is, plus 2, a is minus 2, B is 4. Okay, and the way covariance here is 1. Okay, which is given here. So let me find it out, and it would become variance of Z would be equal to 2 to 4, 4, 5, 20 plus 4, 4, 16, 16, 3, 48, and this would be 4 to 8, 8 to 16, and this is what? Minus 4 to 8, 8 to 16, so this would be minus 16, and the answer of it, when we will find it out, it would be 52. Okay, so that is basically the solution for the question 4.60, and here it is. So you have seen that there is a huge difference comes when we have the two random variables are dependent or independent of each other, because in the case when two are independent of each other, there is no role of this covariance, and this is 0, while once these are dependent upon each other, the covariance between them occurs, and that is the difference between them. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 4.64, and the statement of this question is: suppose that x and y are independent random variables with probability densities g of x 8 by x cube for x greater than 2 and 0 elsewhere, and h of y is equal to 2y for the range of y greater than 0 and less than 1 and 0 elsewhere. So for it, we have to find the expected value of z, which is xy. Okay, so let me solve it here. This is the solution of this question, and here we want to find out what we want to find out the expected value of z, which is what, which would be the expected value of e of xy. Okay, which is ultimately what, which is basically if the two random variables are independent of each other, which is given here already. So in this case, e of x, e of y, that is equal to e of xy. Okay, so we actually want to find out the product of e of x and e of y. So for it, we had to find what? We had to find out e of x and e of y separately. So now let us first find out e of x, which will be what? Which will be for the range of it x g of x dx. Okay, so let me define the range, and the range of it is from 2 to infinity. So it would be from 2 to infinity, and the value of g of x is what? The value of g of x is, let me put here, the value of g of x is for this range is 8 by x cube. So multiplied by 8 by x cube, it will cancel out, and ultimately we will get 2 to infinity. This 8 is what? This is a constant. It will be outside of it, and here we will get 1 over x square dx. Okay, let me find it out. It would become what? It would become 8 multiplied by 8 would become minus 2. So ultimately we would get minus 1 over x. Okay, and the range of it would be from 2 to infinity, or here inputting the limit here, this minus 1 multiplied by 8 would become minus 8, and putting limits here, we would get here 1 over infinity minus 1 over 2. So it would become minus 8, 0, minus 1 by 2. So ultimately the answer for e of x would become what? It is 4. Okay, this is for e of x. Let me find out the value for e of y. So for e of y,
using this similar equation here, the value for the limits here would become from 0 to 1, and the value of y, because the random variable here we have y, so y multiplied by 2y dy. Okay, so ultimately we would get here is 2 will be outside, it will come 0 to 1 y square d of y. Okay, so let me find it out. It would become 2 multiplied by y cube divided by 3 from 0 to 1, or 2 by 3, and it would become what? 1 cube minus 0 cube. So we will have here 2 by 3. This is what? This is e of y, and that is what? That is for e of y here. Okay, so now we have to utilize the similar equation, which is here, for finding out the expected value of z. Okay, so here let me find it out here. Let me use this color or this black one here. So e of z, putting the value for e of x, this is 4 multiplied by the putting the value of e of y, that is 2 by 3, so it would become 8 by 3, and that is what? That is e of z, and this is our solution for question 4.64. Okay, so that's it for today, in which we have seen the solution for question 4.64. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 4.65, and the statement of our question is, let x represent the number that occurs when a red die, okay, red die is tossed, and y the number that occurs when a green die is tossed. Find part A, expected value of x plus y, B, expected value of x minus y, and C, expected value of xy. So here we have two dice, one is red and the other one is green. So let me first draw here the red one. Okay, so this is the red one, while this one is the green one. I have represented them with the different colors or shaded them. Why did I draw them? Because I have to show them that when it is tossed, the number of items or the dots will show here will be independent of the number of dots will be shown here. Okay, so here x represent the number that occurs when a red die is tossed, so this is x, and here we will have y. Okay, so this will be for the red one, or let me represent it with red and this one with green. Okay, so here we have x and y, and both of these are basically independent of each other. So therefore here e of x plus y will be equal to e of x plus e of y. Okay, because these two are independent of each other. Similarly, here we can also see that as both are the dices, so therefore the expected value of x will be equal to the expected value of y. Okay, but what is basically the expected value of x? What is this equal to? This will be the random variable, okay, which will occur here, and that is basically the dot multiplied by the probability of the item which will occur here. Okay, so this p of x, here we can see that this is what? This is the probability, and in order to draw it, let's we draw them here. This is what? Here we have p of x, and this is x. Okay, so this is basically here 1, 2, 3, 4,
5, 6. Okay, so all of these items are basically equal probable, so therefore the probability of each item here is 1 by 6. Okay, so therefore this is what, this is basically the case of the uniform probability distribution. Similarly for y, we can very easily see that it is the similar one, because both are fair dices and are here. This will be p of y, and here we will have y, so it will be here 1, 2, 3, 4, 5, 6. Okay, so it, each and every item here will have the similar probability. It will be 1 by 6. Okay, I have made a minor mistake here. It will basically start from here. Let me remove it. Okay, so it will be from here. Okay, so this is what, these are basically the probabilities we have, and here we have all of them. So now here the probability of x is equal to the probability of any item here, and that is 1 by 6. Why? Because the probability of 1 will be equal to 1 by 6. Probability of 2, or the occurrence of 2 here, will be 1 by 6 until and unless I will have the probability of 6, and that would be 1 by 6 as well. Okay, so here this formula will become what? Here all the values of x will start from 1 up to 6, and it will be x multiplied by the p of x. Okay, so let me write them all together here. So the p of x is what? This is here 1 by 6. Okay, so let me write them all here. It would become 1 multiplied by 1 by 6 plus 2 multiplied by 1 by 6. This is what? This 1 by 6 is p of 1, p of 2, p of 3, and all of them are given here. And 3 multiplied by 1 by 6 plus 4 multiplied by 1 by 6 plus 5 multiplied by 1 by 6 plus 6 multiplied by 1 by 6. Okay, so finding them all here, first of all the LCM of it will be 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. So ultimately from here we will get 3.5, and this is what? This is for the expected value of x. Okay, and also if we find out it for the expected value of y, it will be the similar one, and it will also be equal to 3.5. Okay, we can also very easily see it from here and calculating it, and also we can see that this dice is equal to this one, so all the probability distribution on all the numbers will remain the same. Okay, so let us move to our question here. So for part A, it will become e of x plus e of y, so it would be 3.5 plus 3.5, which will be equal to 7, and that is the solution for part A. For part B, let me solve it here. For part B, e of x minus y will be what? It will be e of x minus e of y. Okay, because both are independent of each other. So here it would be 3.5 minus 3.5, which will be equal to 0, and the answer of part B is 0. Okay, this is for part A. Okay, for part C, we have here, this is what? This is basically, again, the two items are independent, so therefore it will be e of x multiplied by e of y. So it will be 3.5 multiplied by 3.5. So it would be 3.5 whole square, which you can find very easily, and that is what? That is for the part C of my question. Okay. So that's it for today, in which we have seen the solution for question 4.65. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 4.66 and the statement of this question is, let x represent the number that occurs when a green die is tossed and y the number that occurs when a red die is tossed. Find the variance of the random variable. Okay, so on this we are given two parts, part A and part B, and this question is closely relevant with the previous question in which we have found out the expected value for x and y. You can see that video for your reference as well. So now here, in order to find the variance of the random variable, which is the linear combination of the two random variables, here we have to do what? Let me use this brown color, and to find out the variance of the random variable z, which is basically the random variable ax plus by plus or minus c. Let me take it here as well. So it will become what? It will become a square variance of x plus b square variance of y, and this c is basically neglected, and this would be what? This would be the variance of z. Now here we have to use this formula. Let me take it, and this will be the formula which we are going to use here. Okay, but now here, in order to find it out, what do we have to find here? We have to find the variance for x and variance for y as well, and we clearly know from here that variance of x is equal to the variance of y, because these are basically the same dices, same characteristics, and all the things are similar here. So therefore the variance of them will remain the same as we have done in our previous question. So now, in order to find the variance of any one of them, which is here, what do we have to do? We have to find the expected value of x square, and from it I have to subtract the square of the expected value. Okay, in our previous question we have found it out, and the expected value of x was what? This was 3.57/2. Okay, so now let me first find out the e of x square. So e of x square will be here what? It would be from x equal to 1 up to 6 x square up to the p of x. Okay, so in our previous question we have seen that this p of x was equal to the p of y, and this was 1/6 in a fair dice. So therefore, taking it and writing all the values here, we would get 1 square multiplied by 1/6 plus 2 square multiplied by 1/6 plus multiplied by 1/6 plus 4 square multiplied by 1/6 plus 5 square multiplied by 1/6, plus 6 square multiplied by 1/6. Okay, let me move down somehow, or it will become 1 multiplied by 1/6 plus 4 multiplied by 1/6 plus 9 multiplied by 1/6 plus 16 multiplied by 1/6 plus 25 multiplied by 1/6 plus 36 multiplied by 1/6, or taking the LCM here, it will be 6. So 1 plus 4 plus 9 plus 16 plus 25 plus 36. Okay, so let me add them all together.
1 plus 4 is 5, 5 plus 9 14, 14 16 30, 30 plus 25 is 55, and 36. 55 plus 36 is 91. So 91 divided by 6, and this is basically E of x square, which is also the E of y square as well. Okay, so let me find the values of the variance. For it, let me move down, and in our formula we have seen that the variance of x is what? This was E of x square minus E of x whole square. Let me put all these values. So E of x square is 91 by 6, and this E of x is 7 by 2 whole square, which we will get ultimately as 91 by 6 minus 49 by 4. Okay, let me find out the LCM of 6 and 4. So 6, 4, 2, 3, 6, 2, 2, 4. So 3 to 6, 6 to 12. So 12. Okay, so multiplying this 12 with this one, so 91 multiplied by 2 is 182 minus 4 with this will become 3 multiplied by 49. So 349 will become 3 9 27, 3 4 12, 12 and 2 41 47. Okay, so it will become what? It will be 35 divided by 12, or 2.92, and this is what? This is the variance for x, and also this is the variance for y as well. Okay, so we have found out the value of the variance. Let me move upside and solve our question. So now we have found out the variance for x. This is 2.92, and variance for y, because both are equivalent, it is 2.92. Now let us solve our question, and in our question let me solve with this color. So this is the solution, and in solving our question, part A, we have to find out the variance for z, and in this case it is 2x minus y, which will be equal to what? Here this is the negative sign, and as both of the random variables are independent of each other, so therefore it will become, this is a, and here we have 1 which is b, this is a, this is b equal to 1, this is 2, and let us apply this formula. So in order to apply it, we will get 2 square multiplied by the sigma square of x, and plus b square multiplied by the sigma square of y. Let me put their values, and this will become 4 multiplied by, this is 2.92, plus this is 1, okay, 1 square, so it will become 1 here as well, and also sigma square y is 2.92. So the answer of it will become what? The answer of it will be 14.6, and this is the solution for part A of our question. Okay, so this is the solution for part A. Now to find the solution for part B of our question, this is part B, and we have to find out the variance for x plus 3y minus 5. It will become what? By following the same formulation, we will have here 1 and the variance of x, because here this a is 1. Okay, we can see that here multiplicative term is a, which is 1, while here the multiplicative term is b, which is 3, while this will be ignored here. So it will become plus 3 square multiplied by sigma of y, while the other constant term will be zeroed here. So it will become 1 multiplied by 2.92 plus 9 multiplied by 2.92. Let me multiply them together and find the answer. 29.2 is the answer of it, and that is what? That is the solution for part B of question 4.66. So that's it for today, in which we have seen the solution of question 4.66. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 4.67 and the statement of this question is if the joint density function of x and y is given by f of xy, which is 2 by 7 x plus 2y for x greater than 0 and less than 1 and y is greater than 0 and less than 1, which is basically the continuous probability density function, we have to find the expected value of g of x equal to x by y cube plus x square y. Okay, so this is what we have to find out here. Okay, we have to find out the expected value of it. Now in order to solve it, let me have here this solution and let me solve it with this black color. In order to find the expected value of g of x and y, we have to find the expected value of x by y cube plus x square y. Okay, which will be ultimately the expected value of x by y cube plus the expected value of x square y here. Okay, so we have it here, and this is why, because expected value of a plus b is always equal to the expected value of a plus the expected value of b. Okay, so now we have to find them out, and this is, let me call it equation a. Okay, so this is equation a, and here we have to find out first this one and then this one and then add them together. Okay, so let me first find out the expected value of x by y cube, and here in this case, as this is a continuous random variable, it will be what? It will be the x divided by y cube and multiplying it with this f of xy, which is 2 by 7 x plus 2y. Okay, so here in order to find the expected value of it, we have to multiply the value of the variables which are here with the f of x, and this is why, because every time, let me write it here, we have to write the value of, let me write here f of xy, it would be the x y multiplied by f of x and y, and after it I have to integrate it with respect to x with certain limits a and b, and then b c of y, and here it would be dy. Okay, similarly, using the same formulation here as well, we would do first what? We would do here for the x, and here it would be d of x. Okay, so for d of x, the limit is from 0 to 1. So let me write here 0 and here 1. Okay, so after once we will find it out, we have to integrate it again with respect to the other random variable, which is y, and the limit of y is 1 to 2. So it will be from 1 to 2, and the integration of it will be d of y. Okay,
So once you will calculate all of this and you will find the answer of it, which is very easy because you have to multiply it, all of them inside and applying all the rules of the integration here as well. What you would get at the end, you will get 15 divided by 84. This is for this first one, and this is here. Let me underline it here as well. Okay. Similarly, for the other expected value, which is e of x square y, the only difference here would be what? Here, this x by y cube will become this random variable, so it would be x square y multiplied by the f of x, which is here in this case the similar one here, this one. So 2 by 7 x plus 2y, applying the similar limits here in the integral. This is dx, and here 1 to 2 dy. Okay, you will apply the same formulation here, same rules of the integration here. I am not going into the details of those integrations here because you would know it very well. So after finding it out, the answer of it will be 139 by 252. Okay, so this is what this is for the e of x square y. Okay, so now these two values are known here. Let me put them here. So this is what we have. Let me put them here. So putting them here, we will get 15 divided by 84 for this one, plus for this we have 139 divided by 252. So the answer of it will be 46 divided by 63. This is by finding the LCM and then solving it, we will get the answer which is here. So this is what? This is the answer, which is basically the expected value of g of x and y, and that is what? That is the solution of our question. If you have any question, you can ask me in the comment box. See you soon.